So everything that's in this block that's second has been green. And then, but you can only have one ID name first. But class you can have all over the place. So we can have, we can put the more space class on a couple of different tags. So this tag, more space, all more space does is shove it in from the left and the right, margin left and margin right. So it's kind of pushes this in. And so you can put this on here, you can put it another place, and so the more space pulls in something here. So here's another paragraph that's got more space. That one has more space. This one has more space. See that one? And so you can put more space on as many times as you like, and then, you know, div third. Right. And so the hierarchical section means, in this case, this one's a little bit, and loud is red, so where's loud at? So let's inspect that one. Inspect element, yeah. So that's and the loud is not only red, but it's also forced uppercase, text transformed to uppercase. Shouting and loud, and you can have more than one class on on a tag, and then you can be even more precise with your selection. This is basically, this says find a third ID and then only paragraphs within that tag third make their background color yellow. And so that means that background color yellow does not apply to this tag, it doesn't apply to this paragraph, doesn't apply to this paragraph, but when you see div ID third, we have selected this paragraph and this paragraph, and they have a background color of yellow. So continuing on, let's take a look at a simple navigation bar. Now, there's this nav tag that's an HTML5 thing, and if you look at most navigation on pages, let's go to the next one. They're pretty and they got colors and they move around and stuff. But what we want to be careful when we build our HTML for these kinds of things to make them very, very simple. And so what I've got is a navigation is usually, we describe it, we use a nav tag, which is a block tag that says, hey, this is our navigation, useful for screen readers, etc. And then we're going to say we're going to have a list of two links, and so that's what we're doing: unsigned list, unordered list, and a list element that's just no paragraph here, just an include, just a anchor tag, and we're going to put a class equals back and class equals forward, so we can style these two things differently in the future. And so this is what this looks like with no CSS whatsoever. And so this is a nice, elegant, clear HTML. And so if you were just looking at this HTML, like a screen reader might be looking at, you can see what this really intends to mean. Now, then what we do is we add a little bit of HTML to this. And so for now, we're just not going to bother, but in navbar.css is the HTML or the CSS that makes this pretty. And so there's a whole bunch of stuff, and we'll come back and take a look at that in a second. Okay, and so there's our styled nav bar. So I'll come back in another video and pick up right here. So welcome back. Now we're going to take a look at some more examples. We're not going to, the one thing we're not going to look at is exactly how this navigation bar works, at least until a little bit later. So the next thing we're going to take a look at is how fonts work. And there's a couple of ways that you can put fonts into a file. There are default fonts that every browser is required to produce, like serif, sans serif, monospace, cursive, and fantasy. And so you don't exactly know what's going on, but they're often used as fallback fonts. And so you can have those. There are any font that is on the system, like Arial or Helvetica. And so if you're going to use Arial, not all systems have Arial, although most of them do these days. And you have to have more than one font. Now, another thing that's really common these days is to include a font somehow. You find out about a font, and here's a Lotto font, and you go look it up on the web, and you find, oh, include this. And so I included this link because I found this really cool font, Lotto. And this extends the browser. The browser then learns about this font, it downloads the font, caches them, and keeps them in the browser. and then I can make a font that's Lotto. But just in case I'm off the internet, you know, and I can't download this thing, I have sans serif as a fallback for Lotto. So Lotto is a fancy font, etc., etc. So there's Arial and built-in fonts, etc., etc. And so that's how fonts work. Colors. There's a lot of cool stuff about colors. There's a couple different things. We'll ignore the nav for the moment. I'm just using span tags here. There's some default colors in the earliest of browsers. These days we have all these fancy ones, and you can go look these up and you just Google for HTML colors. And there's a bunch of names, and then they're consistent across browsers. But there's like 12 or so really solid names that are in all browsers since the beginning of time. But more modern browsers have a better palette of colors. Although really good graphic artists want to have much better control of colors. And so this is, the pound sign says that this is a hexadecimal number, and it's got 2 digits. Hex means they go all the way up to F. So F is an A through F are numbers. 8B is the red level, 45 is the green level, and 13 is the blue level. And so this is a brownish color. And then there's what's called web safe colors, where you just have, this ends up being 88, 44, 11. But it sort of reduces the number of potential colors if you were mixing colors from various sources. And then in HTML5 you can see this color picker when you have a form, which we'll talk about in a bit. It's a color form for modern browsers, and then you can pop up with this button, a color picker, and I've got a little thing to print out what the color would be. And so it just, when I pick the green, it basically puts 00FF, that's red, green, and blue. It puts that into this thing, which then the program could use. You know, it could read this, or JavaScript could read it, or server code could read it. But right now we're just kind of playing with the picker, and we pick a different color. And so that magenta is all the red, none of the green, and all of the blue. And orange is all the red, some of the green, and none of the blue. So those are all just really strong colors. And so that's what's called an HTML color picker. Anchor tags. In the old days, anchor tags were kind of funky. They were blue if you hadn't yet visited them, and they were purple if you had visited them. And so this one I've obviously clicked on. And so we have a whole series of styling mechanisms that we can have. If we take a look at these. I have put these all inside of an ID tag of cool. So this is basically saying find the ID tag of cool and then style anchor tags to make them font weight bold. So let's take a look here. So I got one paragraph that has this one here, and then I have a paragraph with an ID tag of cool, and that's basically so I don't have to style. Usually you wouldn't say I'm only styling the anchor tags inside of you know, if I'm only styling the anchor tags inside a tag that has an ID of cool, but that way I can have the default on this one. That was my way of keeping the default. So normally you would just say A. So A links is red. If it's visited, it's orange, and so this one's been visited, so you don't see the red. It means it's unvisited. Hover, you can change it. So you notice when I hover in, the text decoration goes away, the underscore goes away, and I have a color of text font color of white and a background color of navy. And then there is one last moment, and I click on this one, oh, that will click. There's one last moment that's really hard to catch, and that is the moment of active. If the web was slow and you clicked on it, then it would tell the user, in the old days this made more sense, that it would turn red and then blink away. I don't know if we'll even see it. It kind of saw it. You sort of saw it. And so there was a color while you click on it. Yeah, there it was. You might not see it in the screen, but that's what the active means, is you've clicked on it, but it hasn't yet been retrieved. And then like a moment later, the whole page goes away. Another thing we can do is we can play with images. Okay, and so here is an image. One of the things that's really fun to do with images is float them to the right or float them to the left. And then what happens is that the image, the text is drawn around the image, so it wraps around the image. And you'll notice where I floated this left. Oh, I kind of got rid of everything. I floated it left before the H1, and so what happens is the H1, top of the H1 and the top of the image line up, and then all the text afterwards wraps around it. And so you'll notice that I've got the image first and then the H1 second, and that the float sort of disconnects the image from the normal line of flow, floats it over, and then takes this next thing and the next paragraph and saves the space for the image and shoves the margin over so that it comes over here. Now once you start floating images, you got to learn about this clear equals all, because if we want this next paragraph, like this one, we don't want this paragraph for whatever reason to be on the image. Now, if it goes far enough, you see this paragraph here moves back to the left margin, and then this next one starts there. But if the browser is wider and the text is there's not so much text, we don't want this to be up in here. And so you say BR clear equals all. So between this paragraph and this paragraph, we do BR clear equals all. And you can put images right in the middle of the text like a character. You don't have to have them by themselves. And you can even make an image that's a clickable link. And so you can click on that image. Now, C in CSS stands for cascading style sheets. And so the idea is that the tag that's closest has more precedence than a further away tag, unless you say important. Okay? So here we have some style. Here we have a body tag, border style of dotted, red, and red, a border color that's red and important, and border width that's 5 pixels, background color, which is kind of a grayish, that's that gray, and extra padding, so we've got put some extra padding all the way around it, and extra margin. And so if we take a look at this, we take a look at this paragraph right here, we see some things, and we take a look at what we've got. So we've inherited this, we got a border style of color, it wants to have a border color of green, but it doesn't because it says the border style is solid. So the border style of solid is down here in the second style tag. So the second style tag has precedence because it's closer to the paragraph. And so we tried to say border color green, but that one was overridden. So otherwise this would have a solid green border, except that this red important is up there, and so that the red important wins. And you can see it really easily here that this was overridden, and this is the one, this border color from the previous one is taking precedence. Okay? And so this is the second one, and it would normally take precedence over this one, except that this important is sort of like it is overriding the one that's closer. So another example of closer is the style tag. Okay, and so here we go. This is we're putting this, style attribute. We're saying border style equals dash, border color equals blue. And so the border style equals dash holds on, but our attempt to make the border color blue is overridden again by the red important, right? So important is up above that, okay? And so this dashed is winning, and this blue is not winning because there is an overriding red above it. There's an overriding red important above it. And so if you want to override an important tag, yay, we override an important tag right here. We basically say I want a border style dashed. Come over here. Border style dashed, and I want the border color to be blue, and this is important. So now this one's closer, and it says important. So among all the important ones, the closest important one wins. So now we see that the border color actually takes here, and we are overriding the far away. This one here from farther away got overridden because of this one. And so you can do that. Now, in general, while I've shown you how important works, you shouldn't do too much with important, because usually you're taking CSSs from other places and you're patching it, and you can end up with really inconsistent looks and feels with important. Usually when you see important, it means kind of something's wrong and you're fighting with a framework or something else. So let's take a look at some blocks. And so let's see, background color. Each one's colored blue. And I'm going to put some padding and a margin. And so div P and H1 sort of live in a box. You have sort of like the actual, so let's take a look at, say, this paragraph right here. That's probably the thing to do. This is just a plain old paragraph. Nothing special, right? There we go. That's a paragraph right there. So let's talk about the padding and the margin, right? So working from the inside out, there is the actual text that is, and it's wrapped. And so if I change the width of this whole block changes, right? It gets taller and narrower. But at some point, the inner part, this inner part right here is, the inner part is however large it becomes. And that, in this case, it's 318 by 38 pixels, right? And then what happens is we sort of work from the inside out. So I'll go down here and see the box model. So the inside of this, the actual text is 619 pixels by 19 pixels. And then I've asked to add 10 pixels of padding, and that is between this sort of text and the border. And then the border itself has a width, and I specified that border width. Right, I said I want a 5 pixel border width, and so the border width takes up 5 pixels. And then there is, outside of that, there is margin. And so margin is space. Notice that the padding and the text itself has the background of the block, border has its own color, and then the margin has the background of the color of the background document. Okay, so this is the margin here, it's the color of the background document, right? So content, padding, border, margin. And then, but the padding inherits from the text in the box, from a background, and the margin inherits from the background document. And you can have different background colors, etc., etc., etc. This is an, oh, by the way, this is an ordered list that we've got going on right here. Okay, so that's CSS boxes. We can change the size of these boxes. It's a little tricky. So and so here we have auto sizing div where we're not mentioning anything about the height. If we take a look at the box model here, we see that this one is simply, you know, the size of the text plus the padding plus the border plus the margin. And that's sort of how that box gets sized. You can say that you want to set the size of the box. Okay, so I'm going to set that to be 3 M's. 3 M's is 3 characters. But if you look, I have too much in here. And so you'll see that even though this box is 3 characters tall, it's 4 lines, and so the 3 would fit, but the 4th one doesn't. And so it just overflows. You can also, so 3 M's, it's good to set sizes in M's when you can, because then if someone makes the screen larger, oops, I didn't mean that. This one, if someone makes this larger or smaller. Now the problem is, well, I don't know about it, if we'd call it a problem, but in the old days, if you set a height in pixels and you zoom the screen, the box where you set height in M's would zoom, and the one that you set in pixels wouldn't. But they decided to make zooming work, otherwise zooming, so many people made boxes in pixels that they made it so that the zooming would pretend that pixels are really M's. So it kind of converts pixels to M's, but you're supposed to avoid using pixels when you really mean characters. If you want 3 lines, don't look at your font and say, I'll make this 40 pixels in order to do that. And again, in this box, we still have overflowing text. And so we have a couple things we can do when we want to change the overflow. We can tell a box that we would like the overflow to make a little scroll bar. And so here's that same stuff, and you can see we got a little tiny baby scroll bar, and it didn't sort of blop out of the box, right? And even if the scroll fits, you see you get little scroll bars, but you can't scroll it because there's only one line there and it fits in the box. And then another thing that you can do is you can just say chop it off, right? chop it off. Now, one thing with some JavaScript, you can put a little more here and that expands the box or pops a bylog or whatever, but we're not going to worry about that for now. For now, we're just saying overflow hidden means lay this out as much as you need and then, you know, throw this text away. It's just not there anymore. Like, where did all this text go? But it doesn't show it because we told it to chop it off. Okay, so on to the next one. You can move these things around. This is a little messy. There we go. Let's make this a little different. Okay, so by default, I'll show you the HTML in a second for this, or maybe just do view source. Let's do view source. Okay, so if you just say div, they just follow after each other. And I've given them border because to make them a little picture, give them some border, some padding, and some margin just so they don't touch each other too much. So by default, blocks just, so I got a little border both on all sides and a little bit of space between them and a nice. So they, you know, however big they get, this one gets bigger, and I put a width on them just so that they wouldn't move around, and there's a width on it right there, 10 ems, 10 characters wide. So they just follow each other. And then you can say, okay, you know, this block right here, this number 3 would lay out right here, but I have told the number 3 block, that I want to move relative to where you would normally be 20 pixels to the left and 20 pixels down from the top. And so this block, it lays out exactly as if it belongs right here, and then we shoved it over and moved it down. And it came over top of the number 4 block. And so there you go. And so the text afterwards, this number 4 block, just comes next, and it's basically, it's as if this laid out without the position relative, and then this came afterwards, but then we sort of just shifted it, and that's why this overlaps, because this corner here is where 3 would have finished and with a normal layout. So you got to be careful with relative. I mean, you don't usually want to make it so that they sort of blop on top of each other. Okay, and so now we're in 4, and then we're going to look at 5 and 6. And so 5 is what's called fixed text, and you'll see the 5 comes right here, but because I've got this as position fixed, this is fixed relative to the window. So it's 20 pixels up from the bottom and 30% of the way from the left margin. So you can see that this is 30% of the way from the left margin, and it's the bottom of it is 20 pixels up from the bottom. And you'll see that that green box never moves, and that is because the fixed text is relative to the window. And that's how we actually get this little link that never goes away. And so there's a link that never goes away. Absolute text, I don't know why they call it fixed and absolute, but absolute text is a little bit different. It's relative to the parent element. And so in this div right here, the parent element is the body tag. And so when it's saying, I would like this to be 40 pixels from the top and 30 pixels from the 30% of the way from the left, that means it's relative to the body tag. And so the body tag starts up here, and so this has been sized 30% from there and whatever, 40 pixels down. And notice that that one goes with the scrolling, right? So that one goes with the scrolling. And you'll also notice that between 4, 5, and 6, there's like, it's as if there's nothing here. But if you look at the document, 5 and 6 are sitting there. And that's because they are plucked out of the normal rendering stream, and so they don't take up any space between 4 and 7. So they don't count in sort of the normal layout as the page is being laid out. And so here's number 7, for example. Actually, number 8. So here's number 8, and so this is positioned relative with a left of negative 1,000 pixels. And so in a sense, this stuff right here has been shoved off the screen to the left. And so that's how we often will put text on that nobody sees. Just move it to the left. But it takes up the vertical space anyways because it was just relative. It would have normally laid out here, but the left shoved it over there. And so that's basically some layout. And so now we're going to talk about z-index. Let's take a look at the source code here. And so z-index is the ability to what happens when things overlap, okay? And so this is a div. Number 1 has a z-index of 100. Number 2 has a z-index of -100. 0 is sort of the background document. And it works out pretty straightforward. And I'm just moving these so they have to lay on top of each other. You know, and so you see this one here is -100, so it's kind of behind everything. This one is +100, so it's in front of everything. And this number 3 is, yeah, I just put that there to be in the original document with no z-index whatsoever. And so it's behind this thing that has a z-index of 100. Okay? And so that's z-index. Like this little note way over here by the right margin says, z-index is kind of tricky. Everyone tries to be on top. And you'll put z-index of 100 and then you'll find that the navigation put itself as z-index of 1,000 or something like that, right? And so z-index is hard to debug and hard to fiddle with, but at least now you know that z-index is when things look weird and they're overlapping in weird ways, z-index is what you're taking advantage of. And so now we'll take a look at kind of how this navigation works, okay? And so here's a couple things that the navigation does. The body, of course, is font family Arial sans serif. The navigation bar itself, I guess I'll do a view source on this so we can look at the navigation bar. The navigation bar itself, this block, it's a block tag, right? That has a position of light gray, and I've given it a height of 3m, so it's like 3 lines. And if I zoom this page in and out, right, that gets bigger and smaller. I'll get back to 100%. It's 3 lines tall, and I guess I didn't need to say Arial sans serif. I did that in case someone else wanted to change the body tag, I guess. So then I want UL tags within the nav, and that's one of the nice things about this nav being its own tag. I can style just the ULs inside here. Okay, and so what I'm doing here is I'm saying I don't want any little circles, little dots, little bullets. I don't want any of those. I want to take away any padding that it has by default. This is one of those things that this UL inherits. Let's go down here and take a look at this, and you'll see that this UL right here. So what's happening is this is the things that I've said in my CSS, and I'm overriding some default things. It's normally would be display. It's a display block. That's okay. And so I overrode the list type style. And continuing on, the list item inside of nav, that's what it is, nav and list item. I wanted to make that, so let's inspect this guy right here. Inspect. So if we look here, and I've got a class of back, and so I have this positioned absolute, which is relative to the parent right here, and I have it 20 pixels to the left of that upper left-hand corner, and so that's how this comes over here. And then I have it colored dark blue because it's a nav, an anchor tag within an anchor tag within an li tag within a nav. That's what this is saying. Dark blue text decoration of none, and so that's where I get this color blue and no underlines. And then this is the dot back, and so I use a back class to position this right here, and then I use the forward class to position this relative on the right, 20 pixels from the right. And so that's how I make the navigation bar work. And CSS is really a lot of work. We learn a lot about CSS, and this is just a really short introduction to get you a sense of what the basic mechanics of CSS are. Thanks for watching.
Hello and welcome to our demonstration of how to move your code into GitHub. This is optional. You don't really have to do this unless you've been assigned to do it. And please don't put your stuff into a public repository, because you really don't want to share all your solutions with every other student on the planet. But if you have a private repository capability on GitHub, perhaps you got it through GitHub for Education, then go ahead, and this is how you do it. Okay? So, of course, GitHub is a great place to store everything. I store the website for this class even in there. So this is my GitHub. And so I'm going to create a new repository. I'm going to call it Django Projects. New repository. Django Projects. And my Mozilla Developer Network Django Projects. So these, if you've been doing this in order, you already have something in the folders. So you don't want to fill this with anything. So don't check this, don't check this, don't check this. Leave this all alone. You can add a git. We will actually add a git ignore manually in a second. And then we're going to create this repository. Now, when you create an empty repository and you haven't put anything in, it tells you how to fill it up, and that's what we're going to do. So I'm going to copy this. Well, I'll have this later. So remember this. Okay, so we've got that repository. Now we're going to go into Python Anywhere, and I assume that if you go into your console, and if you've got stuff in there just from before, you just type clear. I'll say cd to go into my home directory. Take a look, pwd, I'm in my home directory. Okay, so if you do an ls, you will see that there is Django.projects, which is something we created in the previous assignment. Okay, so first we're going to create a git ignore file. So I'll cd into Django projects, and then I'm going to use nano to edit the file git ignore. Now the dot is a file that you're not going to see when you do ls. We'll show this to you in a second. Just put these 3 lines in. Zoop. Put those in, and then Control X, and then yes, and then save it. So if I do an ls, I don't see it. If I do an ls -a, I do see it. So -a shows you the files that start with dot, which are the hidden files. Okay, so I've created this file. I can type cat.gitignore. Cat shows you the contents of a file. So it has 3 lines. There are text lines. Okay, so now this is my site that I created. I'm in the Django projects, and now I'm going to follow the slightly altered versions of the instructions from GitHub. So these are the instructions, but I've got them kind of tweaked a little bit. We're going to set the push strategy. So git add star. So now we've created a local GitHub repository. We're going to add these files. It doesn't find the .ignore file, so you got to add that one explicitly. Git add ignore. Git status is always fun to type. It tells you what Git thinks is about to be done, where changes to be committed. They're not there yet. Now, in order for it to stop asking you so many things, we're going to tell it what our email address is and what our name is. I like using my middle initial because as the internet goes, more and more people have the same first and last name. And then when we start pushing stuff up here, it's going to keep asking for our account and our password. And this cache idea here is going to make it so we don't get asked that quite so often. And this way, I think it's like 10 days or so. So that's credential helper. So I'm just going through all these things. So GitHub -m. So this is a message. Commit is preparing to actually send the data. It doesn't actually send the data. -m is a commit message. So it's our first commit. That's traditional. And if you type git status now, you will see that we're committed, but it's not yet pushed to master. Okay, it's not yet pushed. So now you have to say git remote add origin. You got to add this, but this really needs to be you, not me. So he says csev. Now that turns out to be the exact URL that's right here, github.com Django projects git. I got that right? Get out here, Django project. This is not actually sending it, but this is telling it where to send it. Okay, so now it knows where to send it, and we're just about ready to send it. Git push u origin master. Okay, so now it needs to know your GitHub account. So I got to go get my password off a different screen so you don't see it. So now I got my password right and it's all sent. And so at this point I can go back here and actually I can just hit refresh because I'm in that Django projects thing. So let's hit refresh. And son of a gun, here's all my GitHub stuff. And that's all good. I went and I checked, and so it's all there. And I can type git status, not that it's going to tell me anything particularly great, but we're on good shape. We got a remote. Another command you might type is git remote minus v, remote minus v, that tells you where you're going to be pushing and pulling. We're mostly going to do our editing here on Python Anywhere and then pushing, and we'll, in future assignments, I will tell you if you are choosing to store your stuff in Git, giving you some commands. So that basically gets your code into GitHub so that you can track the changes as you make changes as it continues. Hello and welcome to a supplementary video on installing Django. Now, normally in this class, all of the applications are going to be run on this MDN, on this Python Anywhere, but it turns out that maybe you don't want to get a Python Anywhere account and you want to just run this locally on your local computer, whether it's a Mac or a PC. I'm going to show you a Mac, but the PC is very similar. So the problem that you have is, so here I have a Django application sitting here in my test site, and then I can say Python 3 manage, and then run server, right? And so it starts up and it tells me, look at that, I can talk to HTTP 127.0, and so that works. So I'm talking to this application, and you can even see that it's talking. One of the nice things about running things locally is some of the logs that you have to go into Python Anywhere to look, you're just seeing them go by, including, like, you know, the errors, etc. And so some ways, and this is reasonable, but I prefer Python Anywhere because then folks can don't really need to install stuff, and people's install environments gets messed up. And so, but if you're skilled and you want to run this on your own server, I want to show you how to do this. So we did it. But the problem comes out when we use the autograder. And so we have this document about how to use the autograder with a thing called ngrok. And so let's take a look. It's easiest to just explain this. Oh, they don't have the picture on here anymore. So how it works. So the problem is that, in effect, I am this autograder out here, and I need to talk to your computer, but your computer has a firewall built in, which means I can't make a direct connection. When you're talking to localhost, like this right here, that's 127.0.0.1 or localhost, you're talking, the browser's running on your computer and the server's running on your computer and it's working okay. What ngrok does is it effectively punches a hole, outbound temporary hole through the firewall, and then my autograder out here can connect to ngrok, and then the ngrok software forwards requests back and forth so that my software can grade your homework sitting on your computer. It's quite nice. And so you can download it and you can install it. And I got some instructions on how to do this. Okay. So the simple thing here is this command right here. Now I've got ngrok installed in a way that it's just sitting there. And so if I say ngrok HTTP, that's the protocol we're doing, at 8000. What that says is connect locally to port 8000 on my computer and then export it up into the world of ngrok and give me a temporary domain. And so I'm going to grab this temporary domain. If you start it, this is going to change. This is what's going on locally, and this is what's going on sort of globally. Now on your computer, both the local and the global work, but it should be the same thing. So this is a URL, a real live URL, and it is basically a clone of this. And you can actually see the things that are happening here. And there's even a really cool, if I go like this, there's even a really cool thing that allows you to inspect this as it's going back and forth, right? So it's going back and forth. So it's really nice. And as developers, you probably want to learn how to use ngrok. And so I don't think it's a bad thing for you to use ngrok. It's just I think the average student, there's a lot more moving parts here. But we've got this document on how to run ngrok, and it talks about it. It's pretty simple. It just says, start it. It doesn't matter what folder you're in. And then you get this temporary page, and your local host and your ngrok should be the same, basically. Now, what's cool about this is now you can take this URL right here, and then you can give that to the autograder, right? So now, well, let's first go to this URL, localhost 8000. We'll see what this does. It'll probably blow my autograder up terribly. You think, oh, I got it running here, localhost 8000. So 127.0.0.1 is localhost. It's going to be like splat. So it can't, because this is running out in the real internet. It's, yeah, I remember the picture somewhere, how it works, right? So this autograder's out here, and it can't connect to localhost. There's an infinite number of localhosts, so it can't connect to localhost. So it freaks out, okay? So that's not going to work. But if, on the other hand, I take this URL, which is exactly the same thing, except now it's a real URL, and I submit this to the autograder, see, that's HTTP, now it works. And the autograder can work, et cetera, et cetera, et cetera. And so it found it loaded the page, and install worked. Something went wrong with the static admin font CSS, so I don't have that quite right. But away you go. So this is not so much about getting this thing working. This is about using ngrok to get your application submitted to my autograder while your application is running. And like I said, you get to see lots of little log files, and you get this, and you can inspect this with ngrok. So there's a lot of really nice features to using ngrok. And again, it's optional, but you'll notice that all of the walkthroughs that I do, I'm using Python Anywhere, because I think that is, on average, much simpler for the average student, at least when you're getting started. Okay, cheers. Hello, and welcome to our lecture on SQL. So this is a very, very short introduction to SQL. I love SQL. I was talking to a student the other day, and they were like, SQL is my favorite language. And I said, I have to agree that SQL is my favorite language too, because SQL is so beautiful. You don't even need to write loops in SQL. We write loops in languages like Python just because we have to. The problem is that SQL is perfect, but it's not the way we could write something as complex as Linux or Python. And so SQL is not really the way computers think. We have these things called database engines. And these database engines make things work really, really well. And so SQL is a great way to organize data, but a lot of work has gone into keeping that data organized and making it simple. So it's like there's this abstraction, and it's a lot of work to make that abstraction work. So I want to start out with a little bit of history, sort of before databases. And you might think, wow, before databases, how could that be? Well, yes, in the old days, and if you watch old computer movies featuring computers, you see pictures that have these tape machines in the background, and they're spinning, and the spinning of the tape machine is the sort of physical manifestation of computation. And it had to do with the fact that in the old days, computers did not have enough data to store all of their data in the memory or on a disk. We didn't even have disks in the early days. In the early days, tapes were what we had, and we used kind of a variation of audio tapes, and instead of on audio, they contained data, zeros and ones. And so the way things would work in the old days, so that you could have a database, as it were, was the database was all of your data recorded onto a tape. And the key thing to a tape is that
it was a physical thing, and so you had to rewind it and go forwards and backwards. And most of you probably never even seen a cassette tape or an 8-track tape or a reel-to-reel tape, but it's a physical, long, 1,000-foot piece of plastic, and to get the data at the end, you had to spin it until you got there. And so it wasn't what we call random access, which means that in a random access, whether it's memory or the disk drive, random access allows you to get to any place roughly in a fixed amount of time. Whereas if you're close to something on a tape, you can get to it very quickly. If you're far away, you got to go boo and then wait and then come back. So this led to a pattern where every night we would take the tape from yesterday's account balances. Let's just say we're a bank, and people coming up the window, putting in money, taking out money. And then what we would do is we would put all of the transactions, sometimes on physically punched cards, and then we would sort them, right? And let's just say we have 26 accounts, and person C shows up with a little, adds $10, and person F shows up and subtracts $10, and et cetera, et cetera. And then what we would have at night, we would get these all sorted, and there were physical machines that would actually sort these in the earliest of days. And then we would have the old balance, A, B, C, D, E, F, sitting on a tape in order, sorted in order. And we would start a process after the bank closed where we would read the first record off the tape, like A. We would read the first transaction off the cards, and we would compare them. And if the tape was earlier than the transaction or lower, we would just copy it. So we'd copy it. And then so the B would compare to the C, and B would get copied, and then C would come across. And then we'd realize that the C data, we would have to update the C data and add $10 to the balance. And then we'd write that. And you'll notice as we're writing this, we are sorting, it's in sorted order. Then we would copy D, we have nothing for D and it would just get copied. We would copy E, we'd have nothing for E and it would just get copied. And then we would have, oops, forgot to put F on this picture. We would have F and we'd subtract 10 and we would copy it. And then we would be done. We would be done with the kind of stuff that we had to do that night. And then what we would do is we'd have this new updated data that was all sorted in account order. And then the next night we would move the tape, the new would be the old tape, and we would do it over and over and over again. And sometimes these processes would run for 4 or 5 hours because the tapes were long or it got to be multiple tapes. And so a lot of computing was done sort of after the banks closed at 5 o'clock. Then a group of people would come in, we called them operators, and they would mount these tapes and run these jobs and just sit there and watch these tapes spin as the data was being copied from one to the other. And so, yeah, that's pretty cool. Thankfully, that's not how we do it anymore. The thing that made it so we don't have to do this is the invention of disk drives. And disk drives are a magnetic media, just like tape drives, but the difference was they were on these spinning platters. And so what you could do is the data was in series of concentric circles on these platters, and then you had a head that could move in and out rapidly. And so the speed at which you could access data was a combination with the speed at which the head could move to a certain cylinder, and you had to wait until the data came around. And so sometimes you would have a 5,400 revolution per minute, so that means that 5,400, 5,000 times per minute, which is 100 times a second. Did I get there? Yeah, 100 times a second. Yeah, 100 times a second. 100 times a second, you'd wait 1/100th of a second for it. And so this is way better than waiting like a minute and a half, 2 minutes, even 10 minutes to spin up a tape. And so the problem is then we're like, okay, now that we have this wonderful technology, we can store all of our nightly data on a disk because it's enough space. How do we build technology to make really good use of this? And a lot of research, a lot of computer science, a lot of vendor research went into understanding how to best use this new disk thing. I remember talking to people because we used to use floppy disks, which they were much slower, so they didn't go 5,400, so it might take a quarter of a second to move the head, and it might take almost a second to spin it around, which was still way faster than 10 minutes, right? So it's like about a second to get to anywhere on the floppy disk. And we would build approaches to storing data, and we would start with this physical thing, and you'd hear it grunting and moving and grunting and moving, and then you would come up with a better way to store the data, and then it'd grunt and move less, and your thing would go faster. So this was like a research thing. It was good old days when computers actually made noises, and you could change your code inside computers. And the first thing, of course, we did was just took those sequential master updates and put them on, but that turned out to not be the best. And that was sort of the research, is not just how can we do what we used to do on data that couldn't be randomly accessed, and instead say, let's take advantage of it. And so a lot of research, a lot of vendors, there was a lot of very expensive software that people bought to say, look, you're a bank and you really and truly want to, know how this works. And so what happened was in the 60s and 70s, the computer vendors were fighting, and they would come up with a technique which, compared to our current database technique, was just trivially simple, but it took a lot of work back then. And they would fight with all the other computer vendors, and they would say our index sequential mechanism is better, and vendor 2 would say our networked approach is better. And then they would sit and they would sort of struggle with each other, and then the poor customers would be like, I don't even know what you're talking about. And so then they would just buy the stuff from the vendor who took them out to golf or the best lunch, or took them on a trip to Florida. And then they would just, adapt to whatever that vendor did. And so it was really kind of scary, because we were moving into a place where you were locked into a vendor. And then once you're locked into a vendor, you're in bad shape. And so the U.S. government, in particular, had a ton of money, and we're buying tons of computers, both for normal data processing and for strategic things like military stuff. And so they were buying tons of computers, and they knew that these vendors, if they got to the point where they locked them into a single vendor, that the vendor would just be able to dictate the price. And so the federal government, through NIST, the National Institute of Standards and Technology, decided that databases needed a standard. They needed a way so that we could talk to any database from any vendor using the same technique, and not have to do one vendor, and then if you switched vendors, you had to completely rewrite your software. And so the NIST didn't specify how this abstraction, the standard, was going to work. They just brought the vendors in and said, we're going to stop using your software if you don't come up with a standard. And it was a perfect time, because even though the vendors thought they had everything was perfect and wonderful, there was a lot of upside. And in particular, there was this concept of relational databases, which back then was more of a mathematical theory of a better way to store and retrieve data than it was a practically implemented available technology. And so SQL, and this is Liz Fong, who I went and I did an interview at NIST. She talks about the early days. It's a great interview. The early days of how this SQL standard really made so much sense and really fixed the industry and got the industry working really nicely. And I recommend that you take a look at this video just so you can kind of see. Now, what SQL basically said is that let's not worry so much about where that data is actually on disk, because the earlier database approaches were, we programmers would know that there was cylinders and positions, and we would place things in certain ways, and we would make indexes, and we would look at the indexes ourselves, all kind of different things. Or we would read to one place on the disk, and that would have an address of the next place we're supposed to read on the disk. And they said, you know what, let's not worry so much about the physical storage structure on the disk, but instead, let's come up with a language by which we can express what we want to read, write, update, and delete on the disk, and a really simple language. And then we can build a piece of software that there could be many disk formats underneath that, and then we could all sort of just use this language, and you could buy vendor A and use this language, and vendor B and use this language, and then you could even benchmark it and say, here's a bunch of stuff in this language, which vendor can run this faster? And so the NIST also had a series of benchmarks, TPC, or some of the benchmarks. And so what they did is they basically made it so that this was like a beautiful and simple language, and it's what we call SQL. I think at some point it was called the simple query language, and it is the language that we use to talk to databases. And the interesting thing is what SQL allowed us to do, really in the 60s and 70s when it first came out, was to talk to the old style databases like index sequential and network style databases, and as this new form called relational databases, which had like this awesome mathematical underpinning but was implemented badly in the first time, we could just say, oh, we're kind of, this is all, when the performance of relational databases got to the point where it was as good as the other databases, then we could just switch and we could talk the same SQL. So it allowed an amazing innovation over a 10 or even 15-year period where the abstraction allowed us to improve databases in a wonderful way without really having to change how we as programmers used them. Pretty dang awesome, I'll be honest. And so I've been talking about this idea of relational databases. And I'll admit that when I first saw relational databases in the early 1980s, I'm like, this is crap! Because again, I could hear floppy disks, and I knew that we were moving a thing, and I had so much awareness of what was going on, and I loved that awareness. And the relational databases sort of like hid what was going on behind this layer, and it turned out that whenever I used it, it was slower because it wasn't yet clever. And so relational databases started out as a mathematical idea, as the theoretical best way to represent networks of data, with columns and rows and connections and joins, and we'll talk about all that eventually. And it was a beautiful idea, and the mathematics was right. It just took a long time to get to the point where it turned the superior mathematics of relational databases worked out better than the highly cleverly optimized previous generation database systems. So there's a lot of common database systems that you'll run across. Some of them are open source, some of them are commercial. Postgres and MySQL are open source. Postgres is probably the more intricate and complex and rich. Oracle is a intricate, complex, and rich database that's available for lots and lots of money. And Microsoft has a database called SQL Server. And all these databases that we're seeing evolved, in a sense, after the SQL spec existed. So they just kind of built SQL. There was legacy databases that kind of learned SQL. And there's lots of other databases. SQLite is what we're actually going to use with this course. And it's super cool, super fast, and on your cell phone you probably have 40 copies of SQLite, and in your car you probably have 40 copies of SQLite, because it's a real tiny embedded database. It's not really good for production scale when you got 100 users simultaneously hitting a website. Postgres, MySQL, or Oracle or SQL Server are really kind of online multiprocessing databases. But SQLite is great because it's really simple. It stores everything in one file. We can move the file around, etc. So I love SQLite, and in this class and in this thing we're going to talk about SQLite, but everything we talk about applies to all of these different database systems. So the first thing that you've got to do when you are going to work with a database is you got to come up with a contract between you and the database as to what the shape of the columns are, how wide the columns are, what kind of data you're going to store in this, and it then informs how the database software is going to structure that database, like on the disk. And part of what you're doing is you're allowing the database software, MySQL or Postgres or SQLite, to super optimize its storage. I mean, it's so much smarter than you. Something like Oracle or MySQL or Postgres probably represents $1 billion, if not more, of research and development about the best way to store and retrieve data. And you just don't even need to know any of that. You just say, look, I'm going to have these columns. It's going to have 100 characters of text, then I'm going to have an integer, and then a floating point number, then 3,000 characters of text, and you worry about all that detail. But the key is if you just say, I'll store anything I want, then it can't optimize. And so there's this thing where you have to make a contract at the beginning and say, this is exactly how I'm going to lay out the data as I talk to the database system, and then you can figure out how to lay out the data in the actual disk. And so that's called the schema or the database model. And building a database model is itself a cool thing. So if you're building a complex application, you have these models and they have connections, and we'll eventually talk about all that stuff. But it's a critical thing to say that that's a contract between you and the database software, so the database software can optimize the storage of the database. Now, once you have given the schema, then you can write queries that depend on that schema. So you might have a column called email and a column called name, and then you can insert data into the database using that schema. You can retrieve data using the schema. You can change data sort of somewhere deep inside the database, and then you can delete data. Hang on a sec. Whoa, hi there. What are you doing down there? Oh, dang it. Sorry. You are a bad creature. Look at that. I was wondering what that noise was. Come here. I gotta introduce you to all these folks. Come here. You are not behaving. So this is Shelby. Hi, Shelby. This is Shelby. This is my puppy. I'm trying to keep her out of the cage and let her sit and get by my feet. And she's got some chew toys. Hi, Shelby. This is Shelby, and she is interrupting. You're interrupting my lecture, but you're cute. So quit chewing on the pen. Chew on your chew toys that I gave you, okay? Let me get through this lecture. Okay, you can get down. Just quit chewing on a... Sorry about that. Dog interruption. I was just hearing chewing noises, and I thought I took everything, but then there was one pen on the floor, and so the pen, poor pen, meets Mr. Puppy. Oh well. Okay, where was I? SQL, CRUD, create, read, update, and delete data. And so our next step is to actually do some SQL and create a database. Okay, so now we're going to actually play with a little bit of structured query language, SQL. Now, you can grab, at this URL, you can grab the instructions that I'm using, so you can cut and paste it in. Now, the key thing that you've got to do is you've got to find your way to a shell. If you're using something like Python Anywhere, you go ahead and open a command line. Now, if we're using Python Anywhere, most of what we're doing is running Django applications, but you can really just use Python Anywhere as a Unix platform. And so get to a $ prompt. These commands can run on a Mac. They can, I don't know if you can get them working on Windows, but any Linux system, but you can also run them on Python Anywhere. So there's a command to Linux called SQLite3, and then you give it a file name. So SQLite, as I mentioned, is a very simple database because it does all of its work in one file. It's not a slouch as a database in terms of its performance and scalability. What it's not good at is handling hundreds of people hitting it at the same time and having the database software resolve all those simultaneous accesses. But if you type SQLite, you end up in a command line where you get this prompt, SQLite, arrow, and there's commands you can type, like .tables says, hey, in this database, which is in this case zip.sqlite3, in this database, what tables exist? And it says there are no tables. And then you create some tables. Now this is our first SQL statement. And so you'll learn something about SQL as it looks a little different than other programming languages. And so you say create table. That's one statement. You can create things other than tables, and then you have a table name. And then you have some parentheses, right? And then you have a series of statements about the table that you're working with. And so there's just this little language, and there's the name of a column. So these are 3 columns that we're putting in: ID, name, and email. And we have a type. This is an integer. Varchar means variable length string field. Not null means it's required. Primary key means that it's an auto increment, meaning it's going to be supplied by the database. It gives us like a handle for every row. And then varchar 128 says it's up to 128 characters. Now, a key to this is that we're making sort of a contract here. And so when we say you got to do this with 128 characters, you can't put 129 in. You can put up to 128. And if you put to 129, your database query blows up. And you're like, oh, that's not very nice. And the answer is, well, you told it 128, so it could optimize how it's going to store the data on disk. If you made it this 1,000, it might store it in a different way than if you store 128. And so the key is you can make any contract you want, but you got to live by the contract that you make. And so it's not the database hates you. It's you said I'm going to do 128, and when you do 29, it says you're violating our contract. And so it's up to you. So this whole create table ending in a semicolon, that is a single SQL statement. And so we can type it in. We can type it in multiple lines, and you can kind of see how SQLite's using this ... thing to tell you that it's in a continuation. And then finally you finish it all and you put a semicolon at the end, and then it does it. And then we can ask using .tables, we can say, oh, is there a table? And yes, it says, yes, it's users. And then there's a command, an SQLite command called .schema. And that says, tell me the schema of users. Now that's in case you hadn't just typed in the create statement. It tells you what create statement it would be. And so part of what the database stores in this file SQLite is not only the data for this table called users that you just created, but it also stores the schema. And so you can say, hey, what schema is it? So if I sent you one of these files, like you might upload to my AutoGrader, for example, I can inquire into that file using SQLite, and I say, what schema, what tables are here? And then I can start looking at the tables. As a matter of fact, that's how I grade these assignments inside of the computer. And so this is just sort of going through some. There's a lot of SQL, but the basics is actually surprisingly easy to understand. And so insert into, one of the things that SQL does is it tends to use more than one word. And it wants to be something. I've met people who have used SQL in their jobs, and they just like type it, and they don't realize how amazing what they're doing is. They're like, well, I just insert, or I delete some stuff, or I select it to read it. So it was designed to be easy, because if you go back to the basics of SQL, it was like, look, there's a lot of complexity down there. We want to hide that complexity. We want to hand something easy to users. And I write a lot of very complex SQL, and it's a very sophisticated skill. But simple SQL is something I think literally everybody should know how to do. So insert into, then you have a table name, and then you have a parenthesis list of the columns. Now, these are the columns that you named in your create statement. And then values is a keyword, and then there's a one-to-one correspondence between the values that you're going to put in the columns. And these happen to be strings, so we have little quotes around them. They could be integers, they could be dates, they could be all kinds of things, floating point numbers, etc. And then this has to meet the schema. You can't go putting a number into a string field or a string into a number field. And again, so that would blow up. If you can make all kinds of errors. You can either have syntax errors, like you forget the word into or something, or you can have errors that are bad, that your data is bad, right? So that's the insert statement, and that adds a row to the end of a table. The delete statement says delete from, and then a table name, and then a where clause. We're going to see where clauses a lot in SQL. And the key thing is that every SQL, I sort of mentioned at the very beginning that there's kind of no loops in SQL, and that's one of the reasons that we sort of love SQL, is you don't have to write loops. And that's because there's kind of an implied loop at the beginning of these commands. So when you say delete from users, that means delete all rows from users, right? Delete all rows, delete everything from users. So if you don't put this where clause on, if you don't put that where clause on, it actually deletes everything in there, because it's like delete all the rows from users. That's the way you can kind of phrase it that way, delete all rows from users. Now the all rows part isn't really there, but that just means that it's really important to have a where clause so that you're not actually deleting all the rows. It's saying delete all the rows from users where the email is equal to ted@umich.edu. And so what that is there's an implied loop of all rows on this delete statement, and the where clause reduces that down to actually one or a couple of rows, depending on those rows where this is like an if statement. So this whole thing is like a loop with an if inside of it. That's how it works. And this is why a lot of people like it, is because you don't have to write loops, because these things sort of like are loops. They have loops built in. So but this would delete one or a couple of rows, depending on whether we had more than one row in this where the email was ted@umich.edu. Update is really kind of cool. You can really zero in. You can zero into rows and columns. And again, update users, which is the name of the table. Set is, and then name equals, which is the field name and new value. And so you can do all the columns, you can do one of the columns, you can really zone in on this. And then there's a where clause, because if you don't put a where clause on the update, it implies that this is for all rows, and you don't really want to set the name to be Charles for all the rows. You just want to set the name to be Charles where this is true, because again, this, you could think of this as like update all rows in users set where. And so you just always got to be thinking that so the reading is done with select. I wish that it would be create, read, update, delete. The create is insert, read is select, update is update, and delete is delete. Select is the way that we read stuff out. And so select basically takes a list of columns, like select name, comma, email, or select star, and then a table name. So this select star from users is almost always the first thing you type. Select star from users, select star from books, select star from whatever. You can also put a where clause on a select, because this again has this implied all rows kind of a thing going on. And so select all rows from users where email equals c7umich.edu. And that reads much better when you kind of add that all rows logic to it. Databases are good at searching. We can do things like add indexes to the databases that make searching and ordering even better. So we might say that email, please, while you're maintaining this data, in addition to maintaining the data, maintain an index that has a sense of the order of these records. So if I want to sort them ascending or descending, then I can get that, and I can get that to be efficient. And so the order by is just a thing you throw on the end. You can add a where clause here as well, and you can have ascending and descending sorts, and it worked great. So this is sort of the first 60% of any SQL, is the basic insert, delete, update, and read. And so that it's not hard. And the beauty is this essence of SQL, the middle part of SQL, is portable across all the databases that I just described, because every one of those databases that's a modern database was invented after the invention of SQL. And so life is pretty good. Now, there are differences, because when they first built SQL in, like, I think 87, I don't know, forgot that time, but when they first built it, they did not realize how powerful they were going to be, and so there's a bunch of features that got added by the vendors that were extensions, and some of them were sort of standardized. There's another round of standardization, but then there's a whole bunch of features that are a little different, but they have, because of competition, they have conceptually the same ideas. Like there's like a limit clause that limits the number of rows or starts after a certain number of rows, and it's a little different from one database to the other. So, but this is just a summary. You should know this. You should just know this forever and ever and ever. And then as you run into a different database, then you'll learn different features for that. A tool that you might want to install on your laptop if you want to start playing with these SQLite files and not just using the command line is called SQLite Browser. You can download it. It runs on lots of different systems. You can then open these .SQLite3 files, and you can do stuff to it, including execute the SQL commands right in there. And so a lot of people find this a more interesting and easy way to interact with these files. And so that kind of sums up our really quick introduction to single table SQL. Up next we'll talk a little bit about multiple table SQL and relationships, and then we'll also talk about how we connect this all to Django through an object relational mapper. So see you soon. Hello and welcome to another Django for Everybody walkthrough. Today we're going to take a look at some SQL. Walk through some SQL. So the handout for this is djfree.com/lecture/SQL01 basics.txt. And we are going to do this in a Linux bash shell sitting here in my Python Anywhere account. So I'm sitting here in my home directory, and I've got my samples checked out and on projects. We're a little ahead of that. For now, we're just going to work in this home directory. So SQLite is a very simple database, and it does all of its work in a single file. It's not the greatest multi-user database, but it's great for a class. So I'm going to run this command. SQLite is a Linux command, and then I'm going to give it a file name, zip. This is just a file I'm going to throw away, but with an SQLite3 suffix. So now I'm in a command line. I can type help to see what things are available. And away we go. I've got some of these commands all put in. And so you can do things like ask what tables are in there, right? What are the tables? Well, there are no tables. So let's run a create statement. This is a create, this is SQL, create table users, with name and email, but then there's this special, and each database does this a little differently. This is the auto-generated ID field. That's going to be our primary key for each of those rows. So create table users. So just copy this over, and semicolon ends these, and so you can, this is a continuation prompt. So it's prompting until it sees a semicolon. But now if I say dot tables, by the way, you can see me cursoring up to get to this. So I have a users table. Yay, we're good. So then I can say schema users, say what is in that table. So it looks like a create table statement, but basically this is, you can come back later and say, hey, what's in this table? And it teaches you this or gives this to you in the form of a create statement. So the first thing that you tend to do for anything is you run the select statement, the R of CRUD, create, read, update, and delete. And there's nothing in there. So let's put some stuff in. Let's insert, right? Do an insert statement. So of course we've got the table name, we've got the 2 columns. We do not have to specify the ID column because that's auto-generated by the database. And then the values keyword followed by 2 values, which is one-to-one correspondence in the same order as the columns. And so that happens. Now I can do a select star from users, and you see that I got a record that has Kristen and kf@umich.edu and a primary key of 1. And so that's pretty nice. Now we can say, I would like to see this not with those vertical bars. The vertical bars are kind of nice and condensed, but if I say mode column, I can say select star from users, and it gives me a little bit more white space, okay? And so that mode column is just an SQLite commands to make it a little easier for me. Now I can just put in all these other records, copy them all, and SQLite happily runs them in order and finishes them with a semicolon statement. So now I can say select star from users, and there they are. So I'm sticking them in the database. What's amazing to me is that it's so beautiful. I mean, I just think SQL is just so beautiful. I mean, people avoid it. There's a delete statement, right? Delete from users where email equals ted@umich.edu. Goodbye, Ted. I can do a select, and you can see that now I have record 4 is now gone. I could have said delete from users where ID equals 4. That would work too. I'm going to change my name in the Chuck record from Chuck to Charles. So update users set new key equals value where email equals, and the where clause is really, really important because otherwise it would have updated all the records maybe right before I delete all the data. You can see that the Chuck now has become Charles when I do a select star from users. So far, so good. You can use a where clause on a select statement, select star from users where email equals csev@umich.edu, and at that point we only see record 2, which is me. We can order by select star from users, order by email, which now we see the emails in ascending order, a csev, cvl, kf, nicely in ascending order. We can do DESC. We can say select star from users, order by name DESC to make it be descending. So now you see Sally, Kristen, Colleen, and Charles in descending name order. And away you go. And so we could drop the table users, but let's play with this data a little bit, right? So let's just say I did an update. Update users, set users name equals Charles with no where clause. Watch what happens. This tells you something about SQL. Now if I do a select star from users, let's just do a select star from users. Select star from users, everybody's named Charles because the update applies to all rows until you tell it not to with a where clause. So we always type the where clause without even thinking, but you do not have to type the where clause. And the same is true if I say delete from users with no where clause. Watch what happens. Normally we put a where clause on delete. And then we go select star from users. Away you go. Okay? Now I could also say drop table users, and then it will all go away. Oops, users. Okay? And so that's it. Quit. I will log out. I hope that you have found this particular walkthrough for Django for Everybody useful. Cheers. Hello and welcome to our lecture on simple Django models. Now, as you've seen in previous lectures, we talked about SQL, structured query language, and that's how we talk to databases, and it's beautiful because it allows portability up to a point across databases. And we talked about all the create table stuff, and so this is just a bit of review where we can type these commands to SQLite. We run SQLite, we run a create table statement, and we do it to say dot tables, so we can ask kind of schema users. We did all this in a previous lecture, and so that's basically how SQL works. And here's a series of SQL commands from a previous lecture, just kind of as review. It's pretty simple, CRUD. Now, one of the problems is as I mentioned, is that different databases like Postgres and MySQL do all this stuff identical, but then some more subtle things like how foreign keys work, which we'll learn in a bit, or how they do limits, like pulling like 25, next 25, next 25. That's a little bit different. And so if you want to build an application that talks across more than one database, you got to think a little bit. And one solution to this, also to kind of limit the fancy SQL you have to learn, I like to say that you can learn the first 60% of SQL in about 3 hours, and the last 40% is literally a lifetime. And so advanced SQL is difficult to do. It's really hard to teach a class in advanced SQL. I can teach you advanced features, but then there are so many features that you just can't learn in a class because which database you're using, and they're different for every database. So one thing that's happened in the past decade or so is the emergence of what's called object relational mappers. And that is you have the physical database layer, and then you have SQL, which is an abstraction. It's an imperfect abstraction. And then Django builds another abstraction on top of that called object relational mappers. So we just create a Python object, and we ask that to be placed in the table. Now the object may have a name and an email address and a birthday or something in it. It can have all kinds of data in that object, and then that maps into a name and an email address, and we have to tell it, like, do we want this to be indexed and all these other kinds of things. We communicate through the ORM, so we leave the ORM alone. Now in Django, as we get more advanced, you can also sort of bypass the ORM because the way the objects are mapped into the tables is predictable. The names of the columns is predictable, and so it's kind of like it's a shortcut for. I like to think it's like the 80% of the most common things you do with a database are easily done with an object relational model, but object ORM. But ultimately, once you get to the more advanced things, you tend to not be able to do that with an ORM. You get to the point where writing the SQL is easier than using the ORM. But for about 80%, writing ORM code is way easier than writing the SQL. The other thing that ORM does is it allows you to have multiple databases because the ORM code inside of Django knows the difference between SQLite, Postgres, and MySQL. And so you could actually start an application that uses SQLite during all your development, and then when you deploy it to production, you just go like, you know what, let's just use MySQL or Postgres instead. And that's quite cool. I find them limiting, and so I want you to know both how to use objects and how to use SQL, but understand that most of what you're going to do is to use the object relational mapping, and we get a lot of power with this. So if we look at sort of the way we communicate to the database, or the way we define the database, in SQL we create a table, and that right there is portable, but once you start doing things like adding auto increment columns and things like that, it stops being portable. And so that's the way we do it. But in Django, the way we do this is we have a file called models.py, and it's in the application folder. And then we are going to use object orientation. So we're going to, from Django.db, that's a package, we're going to import models. And models is now a class. And we're going to create a class called user. This is going to be equivalent to the name of the table. And we're going to, in the definition, we're going to extend models.model. And so there's a lot of, this is called extending, it's called inheritance. We're going to get a lot of features and functionality, excuse me. We're going to get a lot of features and functionality from this code. So there's probably 20,000 lines of fancy code that we didn't write that we're using. By extending models.model, we're getting all that. And then within here, we create a couple of attributes that basically says, give me a character field. Models is a class. Char field is a method within that class. Max length equals 128, and that gives us the name. These two things are equivalent. And what happens is when we build this and we do what's called run a migration, then Django will make this table for us. But then we have this abstraction that we can use to talk to it. So this is called a migration, and so you have to be in the projects folder. And so once you create a migration inside of your Django application, then you go up into the Django project and you say Python 3 manage.py. Now manage.py is kind of like the thing that starts everything. So make migrations is actually creating files, because the idea with migrations is that you would debug your migrations like on your development environment, and then once you know, you would move them to production. So you'd make the migrations in development environment, you'd get them right, and then you'd like check them into GitHub perhaps. And then in production, you would pull your migrations out of GitHub, and then they'll migrate. So the make migrations bit, that is creating a set of migration scripts. And you can see that it's making these files, and they're actual files, and you can go find those files like O01 initial PY. And then the migrate is reading the migrations and then actually changing the database. So that's the one where you might be able to make a migration, and it doesn't matter what database you're going to use. Could be your development in SQLite and production in MySQL. You would do migrate in both of those, and in your development it would make an SQLite database, and in your production it would make a MySQL database and put the tables in. And the SQL might even be quite subtle, and it will be subtly different between them, but you don't care. So migrate is the act of creating the database. Now in our development environments, we're going to be creating a file called db.sqlite3. And so if you get all messed up, you don't have to remake your migrations. They're just sitting there kind of as part of your source code. And you can like get rid of the db.sqlite3 file and then run the migrations again if you get kind of messed up. So the make migrations reads this and creates these other little files. You can take a look at them. They're kind of like Django's internal files. They're Python. It's just you're not going to write them by yourself. But then the migrate reads the O01 initial.py and then actually creates SQL commands and runs those SQL commands for us. And so if we jump after we've done this, we see this file db.sqlite3, and we can jump in and take a look. Again, you have to be in the right folder, so you'd be in the Django_projects and then the folder of the project, but there'd be a file called db.sqlite3, go into a Linux command line, type sqlite3, db.sqlite3, and you will find a whole bunch of things. And when you go into SQLite and you type .tables, you will see that Django has a bunch of migrations that are all there from the sessions and stuff we're going to learn how to use later, authorization, etc., etc. But then the particular data model that you created, which is a user data model, there's a table in there for that. And if we use the schema command of SQLite3 and we say, hey, what is in that user model _ user table? And you see a create statement, right? And so this is the actual create statement that the Django sent to SQLite to create the table. And I was talking about some of these things are quite predictable. The name of the column is quite predictable, ID, name, email, etc. It adds the ID field for you automatically. And most of it's portable, like this part here is quite portable, but this ID statement here, primary key auto increment, turns out that if you're in MySQL or Oracle or Postgres or SQLite, that's a little different, but literally the migrate takes care of all that, because the migrate knows that thing, and as MySQL changes, that particular syntax doesn't change very much, but as MySQL changes, then the Django stuff changes, and it all kind of works out. And so you can sort of run these commands and then sneak back into the database, and you can see what they've done, but it's all very predictable. Don't want to spill my coffee on my computer. So you can also talk, you're talking at the low level when you run the SQLite command, but you can also be in that folder, same folder that has db.sqlite and manage.py, and then you can start what's called the shell. So this is different than the Linux shell, and you see the prompt change from $sign to three chevrons. And it's not the same as the Python shell, although it is the same as the Python shell with a whole bunch of Django libraries that are pre-mounted, okay? And so if you just say Python 3, you'll get this, but this next command that is from user model, models import user, that will fail unless you let manage.py start your shell, because again, it loads a bunch of objects and classes into your space, and then all of a sudden user model.models works, users there, etc. Okay, so this is pulling from your models.py file that you built, and so user model is the application name, and models is the models.py file. We import the user model, which is in this case a class. User is a class, and we're going to do a constructor call. And so we're going to say, let's make a new user, set the name to Kristen and the email to that email. And this actually has not done anything in the database. This creates, in effect, just a Python variable. And then to force it to be written to the database, we call u.save. And so save is a method on this new user object. Capital user is a class. We're using a constructor to construct from the class an actual instance, an object, and then we get that into u, the instance object, and then that object sits in our memory until we say save, and then it also pushes it back to the database. Now, one of the things that the save does, it assigns, in effect, a serial number or a row ID. If you look at these, they start pretty predictably at 1, 2, 3, 4, 5. But if you're getting a bunch of things coming in from a bunch of places, then the database just assigns each object, each row, and that's part of that whole auto increment thing. Come on, go back up. This whole auto increment thing that says, hey database, I'm going to put your records in, I'm going to give you the name and the email, and you come up with a number, but then when you're done, I want you to tell me what the number is. And this is how you get that number, by saying, oh, print u.id. Now if you printed u.id before you did the save, it wouldn't exist. And then print u.email, you can see this email is just the data we put in, but now this is not only in your u variable, but it's also in the database as well. Okay? Now, we can dig a little bit into how this object relational mapping is working. And so if you're in the middle, you're doing things like that last statement, you can from Django DB import connection and then ask connection.queries. And then what it does is it just shows you a little bit of debug data and what it did, how it started, the fact that it ran an insert statement. And again, this looks kind of familiar. This is it's making up SQL for you for that insert, the save statement, right? That save statement there. It's making that insert for you, and then you can actually see what it's doing, right? And so this save, set up a thing and save it. You don't need to know insert into or whatever, because the object relational model does it for you, right? And this is kind of what we did before, insert into capital users by hand. And so again, you'll find this ORM is going to save you a whole bunch of time for 80% of the things that you do with the database. And so you can do basic CRUD operations with this object relational mapper. The save is the insert. You can select is basically user object values. That's like select star, so give me all of the objects. A where clause is user objects filter, and there's your where clause. This is email is a column name, and c7@umich.edu is a value in that column. Values is actually go get them, so you can create kind of a query. So if you don't put values on, you get sort of a query that's not yet executed, and then values says go do it now. So you can do a different, you can delete something where you say, and so this is a little different syntax. This is kind of a selector that says these are the variables to select, and dot delete says, the rows to select, and then delete those rows. So value says retrieve the rows, delete says get rid of the rows. And then you can, again, the same kind of thing. This is kind of like a where clause. User objects filter email equals c7image.edu dot update, and then change this column in a way. And you can, go retrieve all the values. And there are things that correspond to lots of the SQL, like give me all these values, order by email, etc., etc., etc. So it's kind of a one-to-one mapping, and you will, again, you're going to do a lot of programming using this ORM in Django, and every once in a while you'll sneak down to SQL. And that's why I sort of teach you the SQL first. And there's lots and lots of fields that might not actually be represented exactly the same way in the database. So for example, an email field. Databases commonly don't have email fields. There might be some databases that have emails and others that don't. But because the object relational mapper is a layer between you and the database, and you say, I'd like this to be an email field, then it can add rules and stuff like validity checking, etc., to say, you know what, that doesn't look like an email address. And so there's all of these things, and these are very useful. And later we'll talk about connecting tables, and we'll use things like foreign keys and many-to-many fields and one-to-one fields, and those are less about the data and more about the connections between tables, which we'll talk in coming up soon. And so just to give you a sort of a bit of a sense of where you're at, this is our application, right? And so we have a browser on the left-hand side with a user doing some clicking. By now you may have created a urls.py file, and that takes the syntax of the GET request / this / that / whatever, and routes it to a particular view coming from the views.py file. You may or may not have made one of those. Templates and forms help produce output, but the models are our interaction between us and the database. And so the actual code we write in Django can talk through the models to the database, which you may not have done yet, but this shell is talking through the Django models to the database as well. And if you're starting to use the admin user interface, the admin user interface talks to the database through the models, and it's informed by the kind of things that you add to admin.py. If you want to use the Django admin interface and have your model shown a particular way, it's got a bunch of defaults, but often you want to override those defaults, and so that's what you put in. And the model.py file informs this connection between the database, and it also sort of informs the kind of code you write here in a view code in Python or in the Python shell. That's kind of the Django shell, which is a Python shell with all that stuff added to it. Okay, so this model.py is critical to defining our relationship between all of our Python code and the admin user interface and the actual database. And so you'll see a recorded demo where I go through a bunch of those things, which I kind of just showed you. It's just actually doing it in a demo form, but it's all mostly in this lecture. And so the Django model is Django's version of an object relational mapper. You can write Python code after a while, especially if you have an IDE that can show you what objects have and stuff. It's a lot easier to write, whereas SQL, you have to know it and write it. You gain database portability. You can create these migrations to both build your initial schema in your database and then evolve that schema as your application evolves. That's one of the more valuable things. If you're building straight up SQL, going from like version 1 of your database to version 2 of your database, it is kind of frustrating and difficult. Sometimes migrating and evolving a database is harder than actually writing the SQL code in the first place. And Django gives you right out of the box this really cool administrator interface. The models and models.py and admin.py informs that. And later we're going to have all this automatic form generation. And so what we're doing here is it seems like we put like 3 lines of code into some file and then a whole bunch of magic happens. And that's really how Django works. And the idea is that way you as the developer can focus on the columns of your database and the forms that you want to put up and spend less and less time sort of manually building HTML that's very sort of brittle, and SQL that's less brittle but still brittle. And so that's the idea. And so it's a little hard when you're getting started, because the amount of code you write is so small, and the amount of what that accomplishes is so great. But after a while, when you get all these little tiny pieces figured out, then all of a sudden you're like, okay, now I want to solve that end user's problem, and you can spend all your time solving that problem rather than just making databases and those kinds of things. So, see you in the next lecture. Cheers. So it's pretty easy to get confused when you're first looking at data models, migrations, and the database itself. And so I want to go through this in a little bit more detail. So the make migrations is what reads the models.py files, and then it creates what are called migrations. And the key thing is this is guided by the list of applications in settings.py. So if you make a new thing and make a new application, and you edit the models.file and you try to run a make migrations and it doesn't see anything, you're like, what did it just do? Well, did you edit your settings.py? Because there is a thing called installed apps in your settings.py. Now, migrations are portable across databases. This means that the migration is a logical description of what the tables should look like. And they're an evolution. What they mean is, like, the first version of this table from the first models.py when migrations was first run is 001. And then if you change models.py and you run a migration again, it looks at the changes from the migration 001 to models.py and then 002. And then 002 is not like wipe it all out and start over. It's like, oh wait, you just added one column, I'll go ahead and add that column. But it's not done it in a way that's actual SQL. So migrations are themselves kind of Python-like. And they're portable across databases, which means that you might, on your computer, use SQLite, and in production you might use MySQL. And the migrations are the same for both of them, because they're just saying, here's the columns, here's the types, here's what they're supposed to be. Now, contrast that with a migrate command. The migrate command reads all the migrations and then knows what database it's talking to and runs the SQL commands to create the necessary tables and or evolve the necessary tables. So it looks and says, oh, here's the first migration, here's the second migration, here's the third migration. I'll make the table, I'll change the table, I'll change the table, I'll change the table. And at the end of all the migration, the migrate then goes through all the migrations and then has a database table that reflects the sum total of the migrations, which also reflects the latest models.py file. So it's a little complex. It has to do with database portability and the fact that we want to separate out the portable parts of this from the non-portable parts to this. So if you look at the make migrations, and here's in DJ Free Samples, my little sample stuff, there's lots of models in there. And if you take a look at all the models.py, you see that for every application in the DJ Free Samples project, you see a models.py file. And that's a Python code, that's class, book, blah, blah, blah. That's very portable, and that's how we, in our Python code, in our Django code, see the database model. And when you run the make migration, that produces these migrations files. And they're just in like autos migrations, 001 initial.py, etc. And so you see some of the ones I have here, there's actually two of them. So it sort of made the first one, and then I must have changed the models file, and then I ran make migrations again, and it recorded how that model changed from the first version of the models file to the second version. If you can look at these, don't edit them, you can check them into GitHub, but don't edit these, but take a look. They're a very portable representation. They kind of look like the models.py file. You're not supposed to change them, you're supposed to generate them with make migrations. And again, those can go into GitHub. Now, the migrate basically reads all those migration files. And not just one, but if there's a sequence of migration files, it applies them all in order as needed. And if the database has the first and second migration applied, but not the third one, it knows that and says, you know what, I'm going to just tweak this database that already exists, that's already running, and then add a column or change the width of a column or whatever it is that you've asked to be done by editing your models.py. So when the migrate is done, you then end up with a whole bunch of tables in your database. And they're all based on the name of the application and the name of the model within the application. And so somewhere in here is book one book, book one instance, and book one lang. They're all sitting there. And so those are all the tables. And we took a look at those tables before, but that's the migrate. That goes from all the little migrations spread across all of the applications in this project, and then puts a database together that has all those things. And I keep saying that the migrations are all about evolution, right? Because if you take a look here, you see one little table called Django migrations. And what Django's doing in that Django migrations table is remembering which of those migrations have already been applied to this database. So as it's going through the migrations, it says, oh, here's one that's not yet done in this database, so I got to tweak the database just a little bit. So it remembers the migrations that have been done. It's pretty fascinating, and in these little tiny applications, we don't always need to be so clever about that. So sometimes what you want to do is just like, I'm confused. I'm going to rerun the make migrate. Because you're not really running production, you're just really doing it over and over again. So you can rerun the make migrate. And the way you do this is you basically simply delete the file. You can delete these files. I would delete all the ones that start with 0, right? If you're going to rerun make migrate, just rerun make migrations. Delete all the ones that start with 0. And this is in application, migrations, and then get rid of all these. And then you can rerun the make migrations. And it will read your models.py file, and then it will do all of the necessary things to recreate the migration file. Right now, that's not the database. That is the instructions on how to create the database. Okay, so that's how you rerun make migrate. You can run migrate from scratch. This is actually easier. So you can kind of wipe out the migrations for one application, and I did that, just wiped out the book one here. That's what I did and started over. But you can wipe out all the migrations and all the database and everything by just removing the file, in this case, because we're running SQLite. Just wipe out the file rmdb.sqlite, because after migrate, that's where everything ends up, is in that file. So then you wipe that out, it's gone. Now you might have created an administrator account or something, and you're going to wipe that out too. You're going to wipe the data out, you're going to wipe the tables out, it's all gone. That's one thing I like about SQLite. You remove this one file, and it's literally all gone. And then you rerun Python manage 3 migrate, and it reads all the migrations and makes you a nice, clean, perfect, empty database. So if you're kind of stuck, and you're not afraid of losing your data, which in most of the beginning programmers, it's okay to wipe out your SQLite thing and run migrate again. Just go ahead and try it. Like I said, if you made an admin account, well, you got to make it again. But that's the worst that you can do. So at least in these beginning applications. So now that we've talked about how to come up with a data model, how to encode it in Django model.py, how to do migrations, and how to migrate stuff, and how to make a database out of it, now we're going to talk about the kind of Python code that you can run to update these models in the database. Hello and welcome to another walkthrough for Django for Everybody. Right now we're thinking about data models, and I'm going to show you how you can walk through and run this particular little example in the Django shell. So let's go ahead. We're going to Python Anywhere. I've already got a bash console. I love the idea of this bash console. This is Linux. I think that everybody should be learning Linux. So if I start my home directory, cd ... means go up a folder, ls -l. I got some folders here. I got DJ Free Samples, which I try to convince you to check out so that you can edit your file, edit my files, look at my files, use that as sample code for your own work. There is instructions on how to clone that, but we're gonna assume it's already there, and follow the instructions. So we're going to go into that folder cd, and then we're going to type a git pull. And the way this works is this is in GitHub, and that way if I've made any changes or fixed any bugs in my sample code, you've always got the latest code. And I've already done this, but there is a bunch of, so, oh, by the way, I got to switch into my Django 3. I got to switch into my virtual environment. You'll notice I didn't have virtual environment. Now I do. And that's because this next command, this pip command, not Django 3. This pip command is going to change the Python configuration. And it's literally best if you do this in a virtual environment, so you're not like messing up your overall Python install on your system, whether it's your desktop or Python Anywhere, with my particular requirements. With my, this is installing a bunch of utility code, etc., etc., etc. And is there some new? It looks like I got some new version here, and most of it's already there from a previous time that I installed all this stuff. But it's good that I ran this to make sure that I have all of the Python requirements needed for this. So now it's done, and it's installed all of my requirements. I'm going to type the clear command to kind of clear up my screen. Okay, so there we go. So then the next thing you run is this command that we run. We're going to run a lot, especially in Python Anywhere, is this python3 manage.py check. And what this does is it reads through the urls.py and the applications and a whole bunch of other things, and it blows up. And so if you get no issues, that's good. The point is you do not want to continue down this other path unless check passes, because make migrations starts to make changes. So make migrations is Django reading through all of the models.py files and creating migrations. Now migrations are not SQL, they're actually Python code, and because this was checked out from GitHub, all of the migrations are actually sitting there, right? There's a way if you want to remove the migrations and remake them from scratch. So the migrations reads models.py files like vi users models.py and reads these and then creates migrations. And then the next thing that happens is we're going to actually, I'm going to get rid of my database.sqlite3. You can, that throws away your database. It actually tells you to do that right here. And then migrate reads the migrations. Migrate doesn't read the models.py files, it reads the migrations. And then it creates the database. And so it's going to create a database, and it is going to create a bunch of tables in that database. And so you see for each of the applications that I have in this Django project, it's creating a bunch of tables. And so here, for example, is users one initial. That is the table that I'm going to mess with up to that point. So now I've done all this stuff, and it's time to actually run Python manage py shell. So what this is it's like starting Django and loading all of the Django libraries and reading all the Django configuration files. So there could be a bunch of errors that happen at this point. And if they are, go back and fix those errors, okay? You can't just like, oh, I think I'll ignore those. This is what the manage py check did. It sort of did that. But now it's like you're in a views.py file, which we'll see in a bit. You can type Python commands that Django, inside Django. It's not just Python, but Python with Django and all of your Django application preloaded. So that's why it takes a bit of time to get to this point. And now it's pretty easy. So now we're going to type Python, right? Now we're going to import the user model, and that worked. And now we are going to create a new user object. So these next two commands are really important. So what that user says, name equals Kristen, email equals, that is going to create a new user model object in Django's Python's memory and give it back to me in the variable u. At this point, it's not stored in the database. So if I say, where did this store in the database? Oops, u.id. There is no ID currently because if it was given an ID in the row, it gets a serial number basically of the user after it gets saved. And u.save says, see this u variable that I've got in memory full of data? Well, store it in the database. And now I can say u.id, and I can see that it was stored in the database at position 1, which is exactly what you would expect. These numbers are pretty simple. They start at 1 and they go up, and we'll see as we do a few more folks. Let's put a few more folks in. We'll reuse the variable u. I'm just going to copy and paste all these at the same time. And now I can say u.id for u.name is Sally. That's the last one I did. And then u.id is 5. It's the 5th one. So now I have 5 models that have been persisted, stored in my database. Now if I want to retrieve those, user objects. So user is the name of a model. That's actually a class. Objects is a attribute in there which has a method of values. So I can get back all the values, and you see what I get is what's called a query set, but in all intents and purposes it functions like a list, and then in that list there is a series of objects, and it looks exactly like the data that I put in, but it pulled that from the database. And the thing that's in there now is the ID is now in there. So this data has a primary key for every other one of the rows that I put in there, and so I can say that. So I can add a filter, and so you'll see this pattern where user objects, and then I sort of throw these things in, and then the dot values comes at the end. And that's because filter is a method that returns a thing that has a method. So this is the values method that the filter returns, and you can just keep putting these together. So I can say this is like a where clause in SQL. So this basically says give me only, and it's a query set, so it's a list, but there's only one object. Now, there could have been more than one because we don't have any uniqueness constraints on email. There could be more than one record that matched email c7@umich.edu. You can delete, so this is basically let's go grab that record, but then run the delete method on that model object, model instance. So this will get rid of the TED record. We can go retrieve all of the objects, and we can see, oh, there they are, but there's no TED. There was a TED before, and now there is no TED. We can update. So let's check this one again. Let's grab that and pull out. So we're going to change this name here. This is in the database, and so we're doing CRUD here. And so we're going to update, create, read, update, and delete. And update's the last one we got to do. We deleted. And so again, we're going to grab all the objects. We're going to filter them down with a where clause to the ones where email c7@umich.edu. And then we're going to set new values. And so if I now say, what is this? Well, the name has become Charles. So it switched from Chuck to Charles. And it's in the database, right? This is not just in memory. This is Django writing all this stuff to the database. Now, just a little bit more, and you can go read up on this, and we'll have lecture after lecture and all kinds of example codes, but you can sort of sort this stuff by email ascending. So A, C, Colleen, CVL, and then K comes later, or we can descend. We can see them descending. So did I get that wrong? Oh, that's in descending order by name. So S, K, C, CO, CH. So they're descending by name. So that gives you just some of the kinds of things that you can do in the Python shell. Let's say quit parenthesis here. Yeah, there we go. Okay, so I hope that you found this this Django for Everybody walkthrough useful. Cheers. Hello and welcome to another walkthrough for Django for Everybody. This is kind of a supplement to tutorial 2.
In tutorial 2, you're playing with models.py, and if you go through the tutorial, they'll have you do a thing, and then they'll do another thing, and they're kind of showing you migrations and how the migrations happen. And if you get them to have a mistake, if you make a mistake, then you can get to the point where you need help or whatever, and sometimes it's easier to just like wipe out your database. But if you've added a question or added some choices or built models, you got to do all that stuff. But it's sometimes just easier to redo some of those things. So I'm going to show you what to do if your model/database gets messed up, and like your manage.py make migrations and migrate are not doing what you think, or they're giving you weird errors. Now if they're getting a syntax error, make sure you do a Python manage py check right before you declare that your database is messed up. So let me go into my go into my site. So here I am. Here's all my files. So just so here I should do it before I declare that the database is a problem. Manage.py check. And oops. Oh, I messed that up. I'm in my virtual environment, of course. Okay, so we got no issues now, so that's good. So I got a couple commands here. Let me explain this. Before I'm going to actually delete these, I want to show you where the migration. I probably showed you this. So I have a thing called polls 2, and I got all the polls running. So this is like in tutorial 2. The migrations are in files with a number, and they're Python files. So if you recall, migrations are portable representations of what happens in the database. And then the migrate creates the file db.sqlite. So you need, if you want to really start over, you got to get rid of both the migrations and the db.sqlite file, and then you can start completely fresh. You could sort of do parts of them, but I'm like, if you're messed up here at tutorial 2, it's probably easier to just get rid of them both. So at this point, my application is going to stop working. So I get rid of the migrations, and then I get rid of my database. And so at this point, the only thing I got that has to do with anything to do with my database is a few models.py files. And this is where we are editing our code. And so this polls to models.py in my particular example is the code that's going to be effective, because I got all the versions running at the same time. That's why you're seeing this. So the next thing to do is Python 3 or Python manage.py make migrations. So what make migrations is doing is it's reading all these models.py files, and it's writing this file. So I got rid of that file, but now if I do an ls, you'll see that it's come back. And sometimes you might see an O2, etc., and then you throw it away and you make it fresh, and you should only see an O1, and then you can say Python manage py migrate. And then that, well, if you do an ls, let me control C there. If I do an ls, you'll see that there, oh, wait a second, how come that, oh, the db.sqlite 3 is 0 size. So I'm going to do Python 3, or Python manage, sorry, my Mac, migrate. So that's reading these files, plus a whole bunch of other ones, and actually creating databases. And so now if I say ls-l, my db.sqlite 3 is back, and I might have to create a super user. If I created a super user account, then I'm going to have to create one again, right? And so I'm going to do that. EJ4E, check. Setup at umanage.edu. I should make my passwords easier to type. Now at this point, things should start working. But again, if I created any data, like a question or something, it was gone. It was gone at that moment. When I got rid of that database, DB-SQLite3, it is literally gone. So it's gone now, and away we go. And so and again, this is just if you can't seem to make these migrations or migrates work, back up, start over, and then redo some of the work. And that probably will be a good way to get things done. Cheers. Hello and welcome to another Django for Everybody walkthrough. This walkthrough is the O4 Model 1. This is a walkthrough where we're going to talk about one-to-many models. And this is a situation where you have two tables and there is a one-to-many or many-to-one relationship between them. And this is all in my Django for Everybody DJ for eSamples. You can track it's public, you can check it out, and it's in the tracks project. So I'm going to go into DJ for eSamples, CD tracks. So here's so I've got tracks, I got the tracks model, cat tracks model, models.py. So this is a model. We went through this in the lecture where we built this model. There's an artist, an album, a genre, and most of these are kind of simple. These are this artist is no different than a a single table, but this album is related to, and this is where this foreign key comes in that says there's an artist field inside the album table that points to a particular artist in the artist model. Okay, so it's the artist that belongs to this album. On delete, set null. That basically means if an artist gets deleted, will the album get deleted? And null equals true means that we allow this to be empty. We allow there to be an album without an artist. That's what null equals true here. On delete means if we delete an artist, do we delete all their corresponding albums or leave them? And this says if an artist gets deleted, we're going to sort of clear out the artist in the album table. The genre table, again, just has a single field. And the track table has two foreign keys, the album foreign key. And what we're going to do here is if we delete, on delete cascade means if album gets deleted, we are going to delete all the tracks. And on delete equals set null for genre means if like a genre like rock and roll gets deleted, we're not necessarily going to delete the track. We'll just have a sort of an empty genre here. So that's what this on delete. It's the on delete of an album entry or a genre entry and how it affects the track entry that we've got. Okay? So we've got this put together here, and we're sitting in here, and we've got our model. We could say Python 3 manage.py make migrations, but since I checked this out of GitHub, the migrations are already in there. And then if I say Python 3 manage py migrate, it'll actually do a bunch of work and make us a database, including all of the tables that are part of the tracks model. So now if I have a DB-SQLite3, and if we were to take a quick look at that, like SQLite3 db.sqlite, and we say what tables, we'd see there are all these tables, tracks model, album, genre, and track. And if I say like schema, tracks model.track, you'll see that it's got some indexes, it's got these things, it's created a bunch of SQL that represents that model. So we'll get out of that for a bit because we're not really here to do SQL. We're here to do the object relational mapping. So we're going to start the Django shell. And again, some of these Django shells have different user interfaces. Some of them have arrows. This one here has this little prompt. And so we're running Python basically. So we have to import our models. This tracks model.models, that is sort of in our Python, and the manage.py knows how to set the paths up. So we're in the tracks project, and we're getting to the tracks model application.models, and we're importing 4 models. Now these are classes that we're now going to start making some objects. And we start by working from the farthest out leaves of the tree and working inward. And we're going to store all these things in, I'll just grab all 3 of these. I think it'll paste pretty nice. Yeah. So this creates a new artist in memory with the name of Led Zeppelin. And then I'm going to have this in the variable Zep. And then I can send it to the database, save it, and say get the ID, which was the primary key that was assigned to this, as 1. Now, later I'm going to use this variable because I'm connecting models to each other. So the next thing we're going to do is, and the names of these variables are just variables. Sometimes I use mnemonic ones, sometimes I use silly ones. I made an artist called ABC for ACDC, but the variable's ABC. Be careful, this is just a variable in Python that we're using. This ACDC is data we put into the, if we do abc.id, oops, we get a 2. Okay, so if we say, well, how many artists, what's in the artist table? This at this point is just a single table thing, and we can sort of see what the primary keys, those ID fields are the primary keys that were assigned. And so the next thing we're going to do, this one here is the tricky one. So we're going to create an album. Now albums has a title, which is just a string, but it has an artist field, which is an artist. And so this is who made who, and the artist is ABC, which is this variable, right? This title could be a variable too. This variable is an artist object, right? And so we're saying connect this album to AC/DC, right? That's what we're saying. When we made AC/DC, we retained that object and its ID in particular, and we're going to make an album and connect it. Then we have to save it, or it doesn't go in the database. And then we're going to make a Led Zeppelin 4 album, and we're going to give it a title and use this variable Zep, which we created up in here, and then we save that. So we've got, if we take a look now, we say what is in our album table? Album.objects.values. What's in our album table? So we type that, and we see that we've got 3 albums, and you see this field here, artist_ID. That is a convention that says that's the ID key in the artist table. That's a foreign key. It's in the album table, but it points to a key in the artist table, so they name it artist_ID. It's a common pattern in object relational mappers, and as a matter of fact, it's common pattern for people who use SQL to use this pattern. So it just signals right away, I can look at this and know on hundreds of database tables what that means. That is, oh, that's a foreign key into the artist table just by the name of it. It's a convention that the Django object relational mapping enforces, but a lot of people follow the convention even if they're not using the Django object relational mapper. But we now have 2 objects, and they have connections into the artist table. So this is the important part. It's the part you should understand, where you're creating a foreign key, but when you're doing this new album, you got to have this variable present. It's got to be there. Okay? So let's make a new genre. Let's make 2 genres. And again, these are just variable names. So I've saved those. I could do genre objects dot values. And we can see what we put in genre, but that doesn't surprise us, right? Okay, so now we get to the big deal right here. So we are going to create the track, and the track, if you recall, the track has 2 foreign keys, both a genre and an album. So when we create our first track, the album is the variable ZEP4, which we made right here, and the genre is rock, which is the variable we made right here. Okay, and so that's how we indicate that the genre is rock. And we do that. The title, rating, length, and count, they're just standard fields in this. And then we say x.save. Boom. And then we got these other ones. But the pattern is the same. They're just, when we have foreign keys, we're referencing variables that are themselves the right kind of object. Album equals ZEP4. That's an album object. Made is an album object. Made is an album object. Met is an album object. A genre object. And rock is a genre object. So I got these, constructed correctly. That's why I gave them to you and didn't make you type them. And now we can take a look at all the tracks we've got. And so it's a little hard to see, but we've got a query set, which is a list. The first object is ID 1, Black Dog, rating 5, count, album ID, first foreign key, genre ID equals 1. So those are the pointers into the primary keys of the album table and the genre table, respectively. And if you go through this carefully, you see the second one, ID 2, Stairway to Heaven, ID 3, About to Rock, ID 4, Who Made Who, rating, with an album ID of 1 and a genre ID of 2. And if you carefully get it right back, you know that the AC/DC things were metal and the genre is rock. Okay? So now we have set things up, but now we can also look things up. So let's just say we're going to grab that one with a primary key of 1. That's going to be Black Dog here. Track objects get primary key of 1. So that's the variable first. And I can say first. And that tells us it's a track. If I say print first, it uses the stir method, and then it gets to the Black Dog. Okay. Now the stir method is __ stir method is what decides which of these fields shows up when we print that out. That's why the stir method is important when we're defining models. Now we can say print first dot ID. We can say print first dot length GHT. Got that right? Oh, then GTH. Okay. But we can also print first dot genre, which is rock. We could be even more clear to say first genre name. So first genre is a genre object, and name is an attribute of the genre object. We can say print first dot album dot artist dot name. So that says first is this object that we've got, which is this object of the track Black Dog, and then album is the album associated with that track, and then artist is the artist associated with the album, and name is the attribute on the column in the artist table. Okay, and so this is an object, first is an object, album is an object within first, and artist is an object within album, and then name is a column within artist. Okay, so I hope that was interesting to you, so that you could see how a one-to-many data model could be worked with and used in Django. Cheers. Now I want to talk a little bit about a concept, model view controller. It's not super essential to understanding how everything works. in web servers, but it's a great set of terminology that we use among web developers. And I think as you move into your role as a web developer, you ought to understand this. So this is a picture of the request response cycle. At the bottom we have the browser, and at the top we have a web server talking on port 80. The user clicks on a page, clicks on a link, the browser intercepts that link, opens a connection up to the web server, sends a GET request, the web server does its work, and returns a web page. And so that's sort of the basic request response cycle. And now we're going to, as in much of this class, really expand what we're going to do when we're in that web server. So that's where we're going to take a look at this. So basically, Model View Controller is really a set of terms that allow us to say this aspect, this part of the work that's going to be done in the web server, it's either the model, it's the view, or the controller. And so it's the most value that it has is to say, oh, that part right there, that's controller. So Model View Controller is independent of the programming language that you use, independent of the operating system that you use. It's pretty universal across as a concept, as an architecture, as a way of talking about web servers. So the three parts of it, it'd be probably better to call it controller view model, or model controller view model, or something like that. But Model View Controller rolls off our tongue better. So the definition in my mind of these terms is the controller is this sort of abstract idea of what happens next, what is the sequence of events that happen, and then where do we start from, what do we do when we get a request, and then afterwards, where do we go at the end of that. The view is all the stuff we see. It usually is at the end of the request response cycle. We produce a view and we return the view back. And one of the things that the request response cycle often does is either interacts by storing data in a database, like an insert, or it edits something and puts it in a database, or it just reads stuff from the database and shows it to us in the view. And so that's called the model. The database itself and sort of the notion that we have persistent storage inside the application, that's what we call the model. The view is what we see, and the controller is kind of the glue that puts it all together. So the controller orchestrates all this stuff. And so sometimes you don't say that's the controller, but the controller is like several places and the actual shape of your application. So when we receive a request, we have a number of tasks that we often have to do for each request. Sometimes if it's like a form that's been sent to us, we have some data that we have to receive, validate, and then process, and then store it in a database maybe. And so that's often thought of as the model work. Then once we've done that, we make a decision, like I stored this, where do we want to send the user? What do we want to show next? What page to show next? Maybe we show them, a thank you page, or maybe we send them back to the top page of the application. And so once we know what page we're going to send back to them, then that page has some data that we might have to pull from the database. And so we retrieve that using the model, and then we produce, perhaps using a template, some HTML response, and then put it back. So these are the four typical steps that we break down to say, in comes an HTTP request. First thing we do is, if it has data that we're supposed to do something with, we handle it, maybe store that data in a database, then we talk to the database and retrieve more data to produce the next output that we're going to make, and then we produce the HTML or the other form of output and we send it back to the browser. And so if we take a look at this in our Django application, the Django application is pretty much a Model View Controller application, in that the routing is very much the controller. It is that which it's like, here comes a URL, it's a request for something, where do we go? And so when you write urls.py, you're informing the controller. So the urls.py, I would say, is part of the controller action, the controller activity. The views is named the view. So the view is a little bit controller in that sometimes the view is storing some data in the database. Sometimes that's the job of the view. Here comes some data. Before the view produces the next output, it actually has to store what came in on this request. And then the view will do some controller activity, like it might decide, I don't want you, this is the wrong page now that we've processed your data.
I'm just going to send it over to some other page. That's kind of a controller activity. So it might say, I'll store the data. It might, let's see here, can I, yeah. So it might say, you know, here I go, I'm going to store some data, and then I'm actually just going to send you to a different place. I'm not even going to give you an HTML. And we'll talk about that redirect. That's called a redirect in a bit. Sometimes there is no data, and so sometimes you get some data, you route it to the right view, and maybe some data has to be retrieved from the database, merged together, and result is processed. So when we think of views.py, that is to me both the controller and the view production. So sometimes it's making decisions about where to go next. Sometimes it's just handling incoming data or sending data out. And similarly, the models is taken from model view controller, because the models.py is where we basically do all the work to talk to the database, whether it is storing stuff in the database or retrieving stuff in the database. We use the Django model capability to implement the concept in model view controller of models. So just a quick summary. I like to think of urls.py and some of the views.py as the controller. The models, of course, is all the things that talk to the database. And then the views are like the second half of views.py. So produce using templates and forms.py and et cetera, to produce the output and send it out. And so that's how I map the model view controller onto the Django architecture. And again, Django architecture was probably inspired by the model view controller, and that's why it takes some of its names of some of its capabilities from the model view controller concept. So now we're going to start producing the actual output of our application in the views and using templates. And there's a lot to cover here. So up till now, we've been starting to talk about URLs, which are simple. It says when you get the request with a URL of this format, choose a view and send it to that view. We're going to talk a lot about views.py and templates. In an upcoming lecture, we'll talk about forms. And we spent a bunch of time talking about models.py and how the models can talk to Python code, talk to the shell, how the models can inform how we write to the database and how we read from the database. So we're starting to fill parts in. As we put the views together, we're really starting to create our entire application. And I know it's taken a while to get to the point where we can update get to the point where we see the whole thing. So I just want to say that from time to time, wherever you have DJ free samples, whether it's on your laptop or whether it's on Python Anywhere, you should do a git pull from time to time, because I'm always working on these samples and I want you to make sure you have the latest copies of these samples. Sometimes I add little bits. I don't change the samples, but I add bits of documentation as I'm like, oh, I should have added that. So views are like the core of the application. I mean, the URLs find their way to views. Models tend to serve the needs of views, act as this layer to allow views to write and read the database. And so the views.py has a model aspect in that it handles incoming data. When we get to forms and post data, then we copy that into the database. The views.py decides sometimes whether or not to send the user to a different screen, or if it's going to produce the actual screen, the HTML, it produces that HTML, often using a template, and then sends it back. So the views are where the work really gets done. And what you see is you write a lot of code in the views. You write one line in the URL, few lines in the models file, and then lots of stuff in the views. And I consider the templates kind of part of the views as well. So the first thing that Django does when it receives an incoming document, a request for a document, it basically parses that URL. And the first thing after the domain name is generally the application. So remember that Django has a project, and then underneath that there's one or more applications. In each of the DJ free samples, you see lots of applications, each application kind of to show a little bit of sample code for a topic. And so that second part of the URL, that is the application name, and for all intents and purposes, it's also the folder name within the Django project. Now within that, usually the next chunk is the view. And so that view within application the view within application is defined in urls.py. And then after that, there are two kinds of parameters. One is like a key value parameter that comes after a question mark. It also uses ampersands for that. And then sometimes we just put after slashes. This is more of a REST style URL that's very pretty, and you put the parameters right on the URL rather than the question mark, which is sort of the old school for doing all this stuff. So there is this thing in Django called the URL dispatcher. I sort of call it router on my picture. It's basically to get you to be able to define the URLs and how those URLs are to be parsed and handled, and how those URLs to be routed to the various bits of Vue code. And so we do this in urls.py. There are three basic patterns. First, you might route a particular URL pattern to a predefined class, and you'll see the example of that coming up. Or there's sort of functions, really old school function that take this request, which is an object that captures all of the data, the parameters, the URL, whether it was a secure request or not, what host it came from, what's the IP address it came from. All that stuff is wrapped up into this request object, which we'll talk about in a second. And that view function looks at that request object, decides what to do, talks to the database, maybe, and then sends back a response, whether it's a redirect or some HTML. And the function is kind of the low-level thing, but you can also then define a class. And defining classes, as we'll see, is really quite nice. The classes have methods like for get and for post, depending on the kind of incoming HTTP request that we're handling. And it also, in those methods, the request and any other URL parameters can also be sent in. So let's take a look at a sample urls.py from Views. And we see examples of all three kinds of these routes. URL patterns is a global variable. It's just a list, but it has very special meaning. This list has very special meaning to Django. And you see these path commands, and there's other ways to describe these things. And then you have the path, and the blank path means sort of just slash right after the application name. And then we have which view to send it to. And so this template view as view, this is basically to save you from writing code if all you want to do is take a template out of the templates folder and return it. So you don't have to write your own code in views.py. And so it's already there, and that's why we go into Django Views generic import template view, and we're going to say, you know what, I'm going to route, I wrote that template, but I just don't want to write the code to go send that, just read that template and send it back. And so this is a predefined bit of Django that does this for us. Sort of the more old school thing is this syntax right here. And basically from .import views pulls in views/views.py. And then this, you will see our functions inside there. And then these are classes also from our views.py for this particular application. And the syntax is a little weird. This is the module we imported. This is the class from that. And then asView is a static method that returns a function that then can respond to the incoming requests. And we'll see these as we kind of go through these. So up next, we're going to actually look at the views.py and take a look at the views. So now we're going to take a look at the code that actually writes the views, the code effectively in views.py. Now the first view that we're going to take a look at is one where we're not even writing any code at all, and this is that predefined view, that template view. And again, template view is code that a class that's given to us from Django, template view, and you pass it a parameter. So we're actually kind of calling a function here and passing a template name to it, and that is a file, views main.html. So this is the application views, there's a subfolder called templates, and then I'll talk about this in a bit. We repeat the application name twice, so that's a little bit weird, but it has to do with the fact that these names are global across all of the applications, and so you want there to be possibly more than one main.html And so that's why you have this extra folder name and you put this there, even though that feels a little bit redundant, but it's okay. And so this is just a static HTML file. I'm not going to read any data from a database. I'm not going to write any data to the database. I'm just going to read this file and send it back to the browser. And that's a common thing where we just have a file that we want to send back to the browser. And so we just don't even have to write any Python code other than add this entry into the URL patterns in urls.py. So that's a view where you wrote no Python code. Now, for the parts where you're going to write Python code for a view, you're going to be passed in variables. The variables are all about the request object. The request object is all the data coming in, and the response object is something you produce in the view and you send it all back. So the request object is an object instance of class HTTP request. This is a predefined Django, and there's just a whole bunch of things. The scheme. Now, what is the scheme? Whether or not it's secure or insecure HTTPS. The body, it's a string. So there's like about 20 or 30 attributes. We're going to use some of them, but you don't have to use all of them. But you can go look up the documentation, and the more sophisticated your application becomes, the more likely you're going to have to go digging in to find some little bit of the incoming request. You could think of this request data as all that data you see in your browser debugger about what data was sent to the server. That all ends up somewhere in this object. Now, when we return from a view, we have to send a response back. And so the response is something that we create inside of our view. It might be simply text that's HTML, or it might be a redirect object, redirect response that says, hey, go to a different page. And so we make that the main job at the end of the view is to produce a response and then return it back to Django. And so here is a very simple view. So here we're saying, we're in the views application. We're going to go to the view funky, right? And so in the URLs PY, we say map/funky to this function named funky. It's a funky function. That's why I call it funky. And so when it sees this, all the data coming into the request shows up in this variable that is the first parameter sent to that function. So that's what this is saying in urls.py. Take everything that goes to views/funky, gather up all the request data from the browser, put it in an object, and then pass that request object in. Now in this, I'm not really going to do anything with that request object because I'm always returning the exact same thing. And so I just have a nice triple quoted string of some HTML with less thans and greater thans, and I'm going to basically return. It is my job in the view to give back a response. There's a couple, two main types of them. One is an HTTP response, which is just like a body of text, and that's what I'm sending here. I'm sending an HTTP response. That's a constructor. We're constructing a HTTP response object and taking that string that I put in there, and away we go. Okay? And so that basically, if you hit this path, you're going to get this page back, and it sort of looks like that when it's all said and done. Okay, so now we want to talk about how we can get at parameters. So I mentioned that this request object that comes in to your view function has all the data from the request. Well, if we send to a view with this question mark, key value pairs, that's guess equals 42 on there, and we're going to route danger to views.danger and urls.py, and so all this data is wrapped up in this variable called request, passed into the function named danger. And so inside of request is some data. Request.get is a dictionary of the key value pairs that are on that URL. So to pull the 42 out, we can say request.get bracket quote guess quote, and that pulls that out. And so that's all we've got here is a really simple HTML page, and we are replacing that little chunk with 42. And so whatever this number is comes back out in the output. So your guess was 42. So that's how we pass get data into a view. Now, up next I'm going to explain to you exactly why it is I called that function danger. So it's important from time to time to talk about ways that you as a web application developer have a responsibility to create secure web applications. And so I want to call your attention to places where you write code that seems like on the surface that it's what could go wrong, and then you realize, oh, wait a sec, that could go wrong. So it turns out that you take data from the user in the request object, whether it's from a form or from the URL, and, like guess equals 42 seems innocuous enough. And then what I did is I just concatenated that into HTML and I sent that back. And so the problem is what if somebody with ill intent tries to produce data that actually does something? And the problem is if I take data straight from the user and put it back in the HTML response, well, HTML and JavaScript are programming language. Your browser is being programmed, and that means that a user typing data into your system can program the browser. And what's even worse is that, having them program their own browser, not such a big deal. But in a way, what they do is they put some data in your system that turns into code, and then they kidnap someone else's browser when they take a look at data that came in. This is called cross-site scripting, where in a sense what it's doing is it's trying to run code so that it can read stuff from your site and then hand it to a rogue site. And so we have to protect against this, and it's a very simple thing. So if we take a look at the code that was bad, basically we have this parameter guess, and in the last time I showed you that was 42. And we just took this request get guess, which is this stuff, and we simply concatenated it into some HTML. Well, if I carefully construct my guess with %C3, blah, 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 all the blah, 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 all that stuff, well, that turns into, this is a URL encoding of less than, B, bold, greater than, bold, slash, so that turns into HTML. So I passed into this application some HTML, and I as the developer took that and I concatenated it together, so the response source has HTML. It's HTML that mostly comes from the application, but this little bit of HTML came from the person who put it in. And like I said, it's not such a critical problem if I in my browser put stuff to take over your browser, but it is if you can move that into someone else's browser. So what happens is that the browser sees this bold text in HTML, and instead of showing us the less than and the greater than, it actually shows it to us as bold. Now this seems innocuous enough until you do something much more clever, and that is I am going to carefully construct some code, JavaScript. And so what happens is this here is encoding of that line right there, the script alert owned /script. And so what happens is that came in and it was concatenated straight out. And if you run this page, you won't see the data, but actually JavaScript will run and it's going to show up an alert box that says owned and OK. Now, you can go ahead and look at the Wikipedia entries on cross-site scripting. Generally, the idea is once you're in JavaScript, you don't just say alert that I've owned your browser. What you do is you do something like grab a cookie and send it to a third party, or you call, say, a web service on the system with a cookie and do bad things. Like you can convince a teacher to log in and change someone else's grade or delete all the grades in a class. Once you're into a person's browser in JavaScript, you can do a lot. So that's really quite scary, and there's all kinds of scenarios where you're taking data from the user, and you got to be careful because, yes, I said the guess is supposed to be a number, but if it's not a number, if I concatenate it without escaping it, it's a problem. So here is a safer version of that. So I've got another view function called game, and it takes that same request, and it still pulls that get data off, which is this bit right here, but then it calls a function, and that's Django utils HTML escape, right? So what that does is that concatenates that into the HTML, but escape processes any dangerous characters and turns them into what are called HTML entities. So less than becomes ampersand LT, greater than becomes ampersand GT. Right? These four things with ampersands are a safer version of it. And so that means that even though I put in the data for bold, it comes out with the less thans and greater than showing, and it's not actually interpreted, right? So this whole notion of escaping, or HTML entities, converting data, running the data from a user through an HTML entity's automatic filter, ensures that the user cannot provide you data that turns into code in their or someone else's browser eventually. So that's the kind of thing you have to think of as you're concatenating stuff together. And the key thing is the request get guess, that came from the user. And so we think the user's going to be nice, but a user with bad intent can send data that they carefully construct to cause them maximum trouble. But if you just escape your data before you concatenate it, there's nothing they can do about it. So another of the views is where we're going to parse the parameter off of the URL itself. These URLs are a little prettier sometimes than the question mark keyword equals value. And so, so let's take a look at this. The way you do this is in your URL patterns, you have a path, and instead of just having the path name, the view function name, you actually have this bracket, int colon bracket, guess bracket. And what that is, and you can go look this up in the Django documentation, there's a whole series of these things, that says the parameter after the word rest is an integer, and please pass it in as the parameter guess. So I've chosen the name to pass it in as a parameter, and then once Django sees this, it pulls that 41 off and hands it to us. So we don't have to tear the URL apart. Actually, in this request object, we do get the URL. We could do a bunch of splits and fool around, but nah, it doesn't matter. Let's let Django do all that work. Let's just tell it we want that parameter after the word rest. It's supposed to be an integer, and pass it to me in the variable guess. And then that same 41 comes in. I am cleverly escaping it before I concatenate it, and then I return a text-based HTML response with some HTML back to the browser. So this escape is there just because of cross-site scripting. I'm still taking this value, still coming from the user. So if any value comes from the user, you have to properly escape it before you show it to them. Now, those are all function-based, which are sort of a lower level. We haven't got to the point where we're talking about forms, but eventually in those lower level functions, you have to check whether you got a get request or a post request. Post request often comes from forms. And so this class-based view allows us to give a method for get and a method for post and let Django pick whether it's a get or a post. And this is an object, and if you're a little rusty on objects, I've got a URL there on pythonforeverybody.com to review just like what a self is. I'm not going to cover all that. In the path command, you just have a string that comes after the application, routing to this. The main view, as view, is something you got to add to it because main view is a class, not a function, but as view is a function. And then we have to create a method get. Self, of course, is just part of Python's object-oriented work. Request is that first parameter, right? And so this one here is just a stock response, and just like the other ones, I return an HTTP response. Now this looks a little more complex than the other one. Did the same thing, but it turns out there is tons of things that we can do. And inheritance, the fact it's a class, there are so many things about object-oriented programming. that over the next few lectures we're going to really take advantage of this, and we ultimately will rarely write the old school function-based view. We'll do class-based views. And so we can also pass parameters to class-based views just like we can pass them to function-based views. You say, okay, with a prefix of remain, slug is a kind of string, and then guess is the parameter, so that says pull the string after the word remain off, right? Views is the name of the view, remain is the view within the application, and then this third parameter is the guess, and it's automatically parsed and handed to us in guess, and then we're going to respond to a get request. Self, of course, is the object-oriented thing. Here's the whole request, and guess is that little piece that comes off of the end of the URL. We're going to create a response by escaping the user-provided guess bit, so that if the user puts something nasty in for cross-site scripting, we stop them from doing that. And so that produces the same kind of output. Your guess was ABC12342XY, So talking about return values, everything we've shown you up till now is your basic 200 OK, which means you asked for a page, I gave you a page. You're probably familiar with 404 not found, which means you ask for a page, that page doesn't exist. There is another kind of response that's not actually a page, which is a response header that says, you know what, it's not like you made a mistake, but you're at the wrong place. And we call it a redirect, and 302 means I know where you're supposed to be and it isn't here. And it was originally used for sites that would move. And it's all handled by the location header on the HTTP response. And so we send a redirect response, which is a 302 with the location header being set, and it uses our URL. And when the browser gets that the 302 and a location header, it doesn't show you what it just got, but it immediately re-gets that URL and then shows you that URL. And the original idea was that if you renamed a domain or something, you wanted to have the old domain redirect web browsers and search engines, you use these 302s. There's also a 301 header that can be used to redirect all this stuff. But now we use it for all kinds of things, and it's very much a controller function. If you go to Model View Controller, controller says, okay, we're done with that, but I want your browser to go over there. So that routing, that sort of routing the browser, changing the browser, putting the browser where you want it to be, that's part of the application's controller phase. So we can send a redirect from a Django view, and so here we go. If you go to this bounce, it's going to actually not end up at this, it's going to bounce it to somewhere else. And in the path we just say, if we go to the bounce view, run to this function. This is not a class-based function, this is an old school function, and so the request data is passed in. And instead of now returning an HTTP response, which we would put in here HTML, we are doing an HTTP response redirect, and now we put a URL. And what we're saying with this whole thing is, you're at the wrong place, please browser, when you get this response back, go here. So it's like it bounces to the browser and then bounces back and then reads that URL. So, and you can have some output, but folks generally don't need output when you're doing a redirect. So if you take a look at that bounce, watching it in your network console in a JavaScript debugger, what you see is you see a set of 3 requests, actually just 2. You'll see the first request is going to bounce, and if we take a look at this request, we see that it's a 302, it's kind of small. You see we got a 302, which tells the browser something's wrong, I'm not at the right place, and then also the server sends the location header that says this is where you're supposed to be, and the browser immediately turns around and does a get to that URL, simple.htm, and then that's what we see. And then this 404, interestingly, the 3 statuses I talked to you about, is because at this new location, djfree.com/simple.htm, there's no favicon. Remember, the favicon is the thing that shows up like right there in the in the top tab bar is the favicon, and I don't have a favicon, at least not now for DJ Free. I should put a favicon there, but we get to see a 404, and all that means is the browser looked for a favicon and didn't find it. So we see a 302, which is moved with a location header, and then we see a get, which returns then a 200, which is a success, and we see the document, and then we see a 404 because it tries to grab the favicon. And so the HTML you get back from djfree.com simple.htm, that's this simple page with a simple link. Okay, so that's how the redirect works. So that's a series of views, both the input, class-based, function-based, and to both the HTTP response and the HTTP redirect response. So up next, we're going to talk about how building templates makes us do a lot less concatenation. Hello, now we're going to talk about the other half of the views, the templates. And the templates are our way of creating HTML. And again, just to ground everything that we've got here, we're in the views, and the views are really sort of the code, the Python code that we drive. We're going to get to forms in a bit, but views kind of merge stuff from the templates, merge stuff from the models, send stuff in and make pages, right? So this is going to look a lot like HTML. It doesn't have to be HTML. It can be things, but other than HTML. But templates in our class will mostly be HTML. And so they're kind of the last little piece of the puzzle to start building user interfaces. And from this point on, we're going to be making user interfaces rather than introducing the parts of a Django application that have the user interface. So this is the text from the Django website. It's about convenient ways to generate HTML dynamically, and there's a couple of different templating engines. We're using the default one, and there is some data that we pass into the template. There's a process that's called rendering, and then we get the HTML back, and we return to the browser with that HTTP response, which we've already been doing. It's not the request response cycle is the same. The difference is, instead of writing Python code to concatenate a bunch of things together, we are going to use a template engine. So this is the kind of stuff that we've been doing all along. We have a class in a view class, REST main view that extends this view. In comes perhaps the request object, and then maybe even another parameter. That's not changing. What we're doing here is we're using concatenation. Concatenation, these little plus signs. Escaping, we're doing all the escaping and concatenating, and then we are sending back a response. So what goes back as a response, what comes in as a request, what goes back as a response. We're still going to do that. We're just going to get rid of that middle bit and make it a little prettier and make it a little more sense. If you look at that, if you look at it, you've got to get it syntactically right. You got indentation problems. That's 3 lines of Python. I'm using triple quotes. I'm using plus. I got to get all that matching together. And then, eventually I'm going to be in the HTML is going back. I'll be using single quotes and double quotes and all those kinds of things. And JavaScript's going to look really ugly here. Indenting of the HTML kind of will fight with the indenting of the Python. So this is just general. I mean, I've only done short ones because I only wanted to show you a little bit before we showed you templates. So the basic process is a bit of software, a template software that Django provides us. We're using the built-in Django one. And basically template is some HTML with some hotspots in it that says put data here. And then the rest of it is just HTML. And then we pass the data in some kind of an object, dictionary, etc. And then a bit of code pulls all that stuff together and then produces the HTML with all of the data placed in it. Often the render data that we're passing in is coming from a model, for example. We might talk to a database, load up a bunch of rows, and then put it in. But in the simplest form, what we've got is we've got like a little dictionary. Call this the context. You could call it the render data, and then you have the render template. So the render template is really HTML, and that's what makes it a lot easier to look at because you're not putting double quotes around anything. There's no concatenation, but there are special characters. And what the double curly brace surrounding it says is, instead of that, take this bit out and replace it with whatever's in the variable dat from the render data. And so that's how, when it's all said and done, this is replaced in the fun stuff, replaces curly brace dat in the final output. And if you thought about it for a while, you could probably write a render engine. They're not that hard. Now you'll see they have some sophisticated features eventually, so you probably don't want to write your own render engine. But you could imagine a Python assignment where I say, write me a function that takes a dictionary that looks like that, and then with key value dat fun stuff, and then take some text file that has curly brace dat curly brace, and then find that and then replace it with that string. You could write that code. You don't want to write that code. Django has already written that code for you. So here's the code in action. And so this is we're going to call this. We're in the application named TMPL temple. And so we have the application temple, we have the view game, and then we have a number 200, and that's what we put in our urls.py to route the game view and take one parameter. Remember that slugs are a special version of strings that are letters, numbers, and dashes, I believe. And so the entire request coming in from the browser is coming into the variable request. This number 200 is coming in the variable from the URL, is coming in the variable guess. And so instead of us concatenating together, we are going to create a context. What I call a context was just as a dictionary of key value pairs. And the key for guess is GUESS. It's a string. That guess will matter inside the template. And then we pull this number 200 and we convert it to an integer, and then we pass it in. And this render, we pass it the request object, we pass it the name of a template, and then we pass the context, the key value pairs, to be substituted in that. So let's take a look. So if we look at this template, it has a series of curly brace, like hotspots, places where you would replace stuff. And so the double curly brace just says retrieve the string that is under guess and put it in. And so that's how we get your guess was 200 in the ultimate output. And then we have curly brace percent all the way to percent curly brace. And this is a series of if then else's. So you can put logic in here too. You don't have to just take this string and put it in. So what we're doing is we're basically saying if the guess is less than 42, we print out too low. If it's above 42, we print too high. And of course, if it is 42, we print out just right. And since our guess was 200, it prints out too high. And so basically this makes this view code a lot simpler and doesn't put a less thans and greater thans and concatenations. It's all substituted by this render routine. Now the render routine returns an HTTP response request. So when we get that back, we just return it. So we hand back to Django the HTTP response request, and then the page is displayed in our browser. Remember that we have a Django project, and this is the Django project. In my case, the Django project is DJ Free Samples, and I have a bunch of little applications. All these things, as a matter of fact, Temple is the one we're working at right now. Those are just the different pieces of sample source code that I built for this class to talk about. And so those are applications. So it's just that Django terminology. Project made up of one or more applications and folders. Okay? And so the problem is these templates, when Django starts up, based on the settings.py, it loads all these files up. Loads them all up. And so it loads them all up, and the templates are actually global, and we'll see this in a bit. They're global across all of the applications. And so the problem is that if you have a template name like detail.html and you have a whole bunch of applications like I do, all of which want to have a template name detail.html, it doesn't work, because which detail.html, it'd be template/detail in two folders. It's not clear which one you're talking about. So we've adopted a convention that we take the application name and we make a subfolder inside of templates. That's the application name. And then we use this favs/detail.html or pics/detail.html as the name of the template. So in a sense, we're introducing a subfolder. And it's a little jarring at first because you see it's the same. It's a good convention. I mean, it's unfortunate we have to have the convention, but because these names end up being global across your entire Django project, in each application, and to get them a name, to get them properly named, it's necessary to introduce this extra level of redirection. And when we get to logins, there's templates that are stored outside in other applications. So sometimes you want to get a template in some other application. So there's all kind of reasons. This is a great idea. It just isn't the prettiest thing in the world. So just when you see it, don't freak out. I try to call it out in the slides. And so we put these paths that includes the application name twice. It's weird, but it is necessary to do this because of the notion that all these template names are global across the entire application. But if then we call this the template name with the name of the application prefixed, away it goes. Django could have made that a little easier for us, but they basically didn't, and so we have to do this. But everybody does it the same way. So now what I want to talk about is the actual templating language itself. I showed you a couple examples, the double curly braces, but it turns out there are lots of things that you can do with double curly braces in the template language. So now we're going to talk about the actual template language. As I mentioned before, there's more than one templating language. We're using the default one. And I think it's actually one of the better ones, this whole notion of double curly braces. There's all kind of templating engines, and a lot of them use these double curly braces. Sometimes there's a one called mustache because the curly braces look like a mustache. So this double curly braces, you learn it in Django, and you'll find it all kinds of other places. I've used it in front-end processing. This is back-end processing because we're doing all the substitution in the back-end. So there's basically a couple things you can do. The double curly braces do substitution, and one thing that's cool about this, if you recall, I talked about how you have to escape data that came from the user. Anything in the double curly braces is automatically escaped. As a matter of fact, you have to do something to not escape it, because it turns out that 98% of the time you want to escape data that you're printing out, because it doesn't change what it looks like, but it does make sure that it's safe. If you add this vertical bar safe afterwards, that's like a modifier. I think it's called a filter in Django that says, look, don't run that filter on it to do the HTML entities. Just do it as is. I know there may be HTML in that, but I've taken care of that because I am the application developer. You can call functions, like with the code is the percent, curly brace percent. And there you tend to call a code. This is like code. This is like calling a method or a utility code. And so the first part of this is what you're calling, and then later you can have some parameters. So this URL says, I want to find a URL for the view cat detail, and I'm going to take the number that is the current cat primary key for the cat record and put that on as the URL as well. The author in this case is and we'll see this later, is a model item, and get absolute URL is a method inside that model item. You can have sort of ifs and if then else's. It's kind of Python-like, which is nice in that you don't really have to learn new things. There is looping code that's in there, like a for loop that we'll talk about in a bit. And then there is blocks that can be replaced. So you can have a template that sort of pulls in another template and then substitutes in part of it. So you can have whole blocks of substitution, not just little strings of substitution. And so we'll talk about each of these in turn. So here we go. We'll start with a real simple one. And you'll notice that in this particular simple one, we have no parameters on the command on the URL. So we don't have any parameters here. I'm going back to a non-class style, just a simple function, and I'm not sending a context. The context would be the third parameter on the render call, and so I'm just saying, hey, and this is what you do when you just have some static HTML that you don't really need to change anything, and so that's what's sitting in here. It's just a simple page. There's this thing called a built-in template view class that sort of does exactly this thing, that just grabs a template, turns it into an HTTP, grabs a file, turns it into an HTTP response, and sends it back to Django. So that's just a super simple template. Now here's one where we're going to take a parameter to the context, and I'm not taking it from the command line quite yet. I'm just going to make the parameter always be 42, and the key is this is a key and this is a value. So zap in this case is the key and 42 is the value. I often call this variable context, but the fact that's just a mnemonic memory thing for me, context or CTX is what I tend to call it. And now I'm passing in the template, this template here, the guess.html template, and it has one little curly brace substitution, and remember that does escaping for us automatically, so there's no need to use escape the way there was when we were doing this via concatenation. That alone is a good reason to use templates. And so this ends up sending out your guess is 42. So this is just really focusing on what's in that context and how the things come out of the context. This name here, zap, in the context means pull the thing out of the context under the string name zap, and then it substitutes the results, like the 42. So instead of it saying guess was zap, it's your guess is 42. So that's really focusing on the substitution. So this is showing us how we do the safe stuff in case you actually want to pass some HTML into a template and actually want it to render as HTML, not as HTML entities or HTML entity style. So we're sending in a thing that's bold with a B and a less than B. That's HTML. It's got less thans and greater thans in it. And then we got zap. And so you can see that the zap comes out as 42. It's HTML entities, but it has no special characters. But if we escape text, text is the one with the HTML entity characters, that automatically escapes it so that you see the less thans and greater thans in the browser output. Escaped, less than B, bold, greater than B, right? And if you say text and then add the safe filter to the end of it, that says don't escape it. And so then this bold goes right into the HTML document, and instead of you seeing the less thans and greater thans, you're actually seeing the text turn to bold. Now, usually the bad folks that are trying to get into your computer are not just turning your text to bold, they're trying to run JavaScript. And all we're showing here is that whatever less thans and greater thans would be in that context value txt, they're going to end up literally in the document, and the browser is going to interpret them as HTML. I mean, there's just no way that somehow your browser knows the HTML that came from your program versus the HTML that came from a context variable, because by the time it gets to the browser, it's all one thing. And so it doesn't know, oh wow, that's dangerous. That came from a variable. No, by the time the response goes back to the browser, it's just a blob of text. Now we can talk about some loops here. I am passing in two arrays, apple, orange, banana, and lychee. And then I'm passing another array called n with peanut and cashew. And then I'm going to create a context. And in that context, I'm going to have fruits point at the list F, nuts point at the list N, and then zap is just the string 42. And do I even use zap in this one? No, I think there's another place that it. No, oh yeah, it's. I just don't have it in the. So here's the template, a part of the template. It's not looking at zap, and so here's the key. So we got this for loop, for x in fruits. Well, fruits is looking up something in the context under the key fruits. They're string. They don't look like strings in. They don't look like strings in the template, but it looks up there and it finds a list. So that little list F is what really is going on here, and F is a list of apple, orange, banana, lychee. And then X becomes the iteration variable. That's only within the template. And then I'm going to print it out, and then I'm going to end it. So that's like the start and end of a for loop. Apple, orange, banana, lychee. Now you'll notice that I have an li tag, which is the list item tag, and it just generates all that HTML. And again, the double curly braces are doing HTML entity escaping automatically. So, so we take a look at nuts. So we ask, is nuts present? Because that's a way to tell if variable's present or absent. If it's absent, I'm going to ask another filter on the end saying how long was it. Okay, and so this is the n. Nuts is the n list, and it has a length of 2, which means it has 2 elements in it, and so we see the number 2. And so you can do various things. So this is an if then else, the syntax of an if then else. with curly brace percent. Now we can pass objects within objects, and so it's a little tricky. We have a context in this X variable, and the outer key is pointing, outer is pointing to another dictionary, and in that dictionary there is a key of inner with a value of 42, and then we render the nested.html, and you see the outer, but then outer dot inner, so outer is that object, and then object dot inner, then this thing becomes 42. Okay, so you can kind of walk through objects if you have hierarchical objects that contain objects, or lists that contain objects, or any number of hierarchical structure of lists and objects. You can walk through them. So here's just another simple example. This one has data coming in instead of hard-coded. So we again have game 200, and we're running into game view. It's a class view, and the 200 comes in as the parameter because we said it's the parameter that comes after the word game, and so guess comes in as 200. It's a string at this point. It hasn't been converted to an integer. So when Django pulls these off, well, it does some validation based on the types, but it doesn't actually necessarily convert them. And so we're going to create a context, x equals a key of guess, and convert it to an integer to pass it in. And then we're going to pass the context in and the template in. And so the word guess is going to come out, and we sort of saw this. The guess is 200. And then depending on the if then else logic, it's going to say, in this case, too high, because your guess was 200. And of course the right answer is always 42. So now we're going to talk a little bit about how you manage a common text going from one template to another through template inheritance. So now we're going to talk about a technique called template inheritance. And this and other times, it's a great time to review object-oriented programming, because I'm just going to use object-oriented programming definitions and words and not completely explain them. So you got to know what a class is, you know what self is, those kinds of things. And I've got a great online lesson that you can go read and listen to and understand objects, and I'll explain it to you in 30 or 40 minutes. So inheritance, actually from that lecture, is the notion in object-oriented programming to not repeat yourself. You have some kind of a shape, and then you make a bunch of objects that mirror that shape. But you can also, with inheritance, you can have a shape that makes another shape, like a shape in general that's a triangle. And so you can inherit that all triangles have everything shapes have, and all squares have everything shapes have, and all circles. And it's just a way of capturing information once, writing code once, and then not repeating yourself. Functions are a form of DRY, don't repeat yourself. Modules are, but inheritance is the key. And inheritance kind of can get in our way as programmers because it leads to smaller and smaller code. If we're going to make 5 things, each of these 5 things is really small because we make a big thing over here and we inherit all 5 of those things from it. But then you look at it and I don't understand that, right? I don't understand these only one-line functions. What are they doing? Well, the answer is there's 50 lines out here that we're inheriting from. So we'll see some of that. I'll try to kind of allude to that part where, look, there's magic over there. And a lot of what you do in Django is use classes and objects that you didn't even create, meaning that they've got data in them like .scheme or request.scheme. And so this is just also a way of trying to simplify the way you handle sort of things, objects that are handed to you, and then you hand objects to other parts of Django. So template rendering basically says, okay, here's some rendered data and here's a template. What happens now is there's this thing called a base template, and the base template and the template combine together to be sort of like the ultimate template, and then you pass in the rendered data and produce the rendered output. So let's just say that we had a bunch of pages and we were doing the same thing over and over again. Now we will soon do this with navigation because you want to put a menu at the top of every page, and literally that menu could be 40 or 50 lines of HTML, and you do not want to repeat that menu every time at the top of the page. So you want to put that one place, and then you want to make many pages that have the same top navigation so that your pages, as you go between them, look like the navigation is the same. So we're going to do this in a very, very simple way. So we have one template, this cond.html that we've been playing with. You'll notice it has some HTML and a title and a body tag and some of this, and then it's got this stuff. Well, let's say we wanted a bunch of pages that had that everything but the body. So what we basically then do is we take parts of this, like the repeated parts, and we put it into a template. And then we take the part that we're going to change every time, and we put it into a template that then extends. So see, this one here has one line that says extends temple-base.html. So this one uses everything in here, but then adds some stuff. Okay, so the basic idea is we split this one big template into reusable parts and non-reusable parts. And then we have a bunch of templates that come off a base. We call it base commonly in object-oriented world because it's like the thing that we're basing it on. So, you know, this is the base, and then we're going to build on it. Base, build something else on top of it. So how this works in practice, we have a view here. We're going to call this view game2, right? So we're going to use the URL game2. We have a class-based view. We have a get method in there. The request data comes in as request. We told it to parse the slug off the end and pass it to us in the variable guess. We make a template, which is exactly what we did before, where we have a key of guess and the value is the actual guess itself. And then we pass that template in the variable x into render, and we tell it to go read temple con2, which is the condition, the second conditional one. And the thing is there's nothing in the Python code, in the views.py, that knows about the base. What happens is the only place that the base is the only place that the base is noted is in the con2 template itself. That says, hey, go grab this one and extend it. Now the way it works is it starts out a little counterintuitive. It says it really says start with this template here, and then push this content into the base template. And this block content and end block, it basically, that tells what I want to replace. You're replacing blocks in the base template. So all the stuff in the con2.html that is between the block and the end block is what is then pushed into the base template. And then in a sense, the base template with those blocks replaced is what is returned as a result of the render, and then returned to Django as the HTTP response. We're going to use these a lot. When we start doing navigation, we're going to go crazy with these things. So up next, we want to talk about URL mapping and reversing, where we have to actually make a link in one page to a different page. So now we're going to take a quick look at URL mapping and URL reversing. This has to do with basically routing, and it really allows us to generate links from one page to another. So we're in the middle of a page and we want to make a link to a different page. We've got to figure out what the string of that is. So again, we're sitting here in the middle of our code. We're in the views, and this URL mapping is basically a set of functions that allow us to read the urls.py. In a way, if all these functions didn't exist that allowed us to read urls.py, we would write a bunch of functions to do that. And so these are just now part of Django. And so often these are used in the view. Sometimes they're actually used right inside urls.py to come up. So it's like, if you know the name of a view, what would be the URL to get to that view? And sometimes views have just a URL, and sometimes they're a URL plus a parameter, and that's all set up here. And so it's like, give me a link to a view, please. And then Django looks in the urls.py, potentially across applications, and gives you that string. And it's just to avoid hard coding the strings. That's really the idea. And so this is just a common problem. This is the documentation right from the Django website. You don't want to hard code these things. You actually can, but then if you rename an application, the whole idea is you could make a Django project that had 4 or 5 applications, and then you could reuse some of those in a different Django project and add some more applications. So, you know, you don't want these applications to have too many hard-coded decisions. And it might be easier to hard-code some of these things, but it is actually in the long run much easier from a maintenance perspective. And so it's better maintenance. It's another, don't repeat yourself, or doing a table lookup rather than hard coding strings. It also lets you hunt around in your code to see where it is that you're talking to that other application, because we're going to do login eventually, and login is another place. It's not in our application, but our application is going to have to generate login URLs by asking the login application, hey, what's the URL to log in? What's the URL to log out? And that's where we'll mostly start doing this. So I want to talk about it now, so when we get to log in and log out, you'll have that will make more sense to you. And it also is some of the stuff that you're doing from the tutorials. You're putting these reverse lookup things in, and you may or may not know what they are. And my goal here is to give you a little sense of what really they're there for. So let's take a look at an example. So here we have our urls.py, and most of it, I mean, this is the application route. So if you're looking in the samples, it's in the route application. The main thing that we've added is some names. Names are here to look up these paths. We don't really want to look it up by this path mapping, because that could actually change. So we're basically saying this view in your views.py second view is going to be referenceable by this second dash view. I named them differently very much on purpose. So here's what happens if you just go to the route/route, the name of my application. It pulls up this main/HTML. And so the first thing I want to show you is what a hard-coded URL looks like. Now we know that blah 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 samples/route/second is going to go to that second view, because the application's name is route and the view name is second, and that's good. That will work. It's not going to break, but this is where you lose flexibility as you try to recombine applications from one into the other. And so in a sense, what we're asking to do here is we're going to instead use this URL utility. And so in our template, we use curly brace %, and then we're running a utility that's been plugged into the template system that is like when we're running the URL function, as it were, and we're going to pass a string to it, and that is within the route application, the view that is named second view. So that goes into this file, the route urls.py, read down the views until it finds second view, and then it reverse generates the path that works for that. Now in this case, these two strings are going to be the same, and yes, that looks a little uglier, but the key is that we can make changes here, and this will not, the top one, route/second, will not reflect the changes, but if we're looking it up by name, we can do all kinds of crazy things and remap stuff quite naturally. And so again, it's just this URL command, the name of the view, the application, the view. So this is what it looks like when it's all said and done. There's no parameters to this. So if you take a look at this route second view ends up under this hard-coded, the route/second view, the hard-coded ones ends up under the string in the URL output, the page output. We just see it's /route/first is the thing that comes out from running the code URL and passing route:\first view in, so that's what it looks up. And we can make a link. This is now an href, and the actual path is sitting there in the href. So now we're going to see how we do this when we're going from one application to another. So an application we're going to look at in just a bit is this thing called the generic views. It's an application called gview. And we want to make a link to that application, and we know that there are two views. There's a list view and a detail view. And all we have to do is go take a look at the urls.py, and we know that it's an application gview, and this view has a name and that view has a name. The view that is all the cats is got a name of cats, and the view for a single cat is cat. But the cat one takes a parameter. It's an integer number, which is cat number 42 or whatever. And so we're sitting here in the route application, main.html, and we can now go create a URL that actually is pointing to another application and a view within that other application. So this is a URL for gviewcats, and that'll just look it up. So now we don't even have to know what the URL patterns are inside of gview/cats. Now, we can look at gviewcat which is this URL, but you'll notice that this has a parameter, and so we actually have to add a second parameter, which is that 42 number. And so this will generate the URL straight to the detail page for a single cat. Now, there's a lot of nice stuff about this. So for example, if you omit this, it's going to look this gview cat up and find it and say, you know what, I'm supposed to have an integer, and it'll blow up on you, right, if you get that wrong. Or if you put a 42 on this one, on the gview cats, you're not supposed to have a number on that. But gview cat, you are supposed to have a number. So this is one of the nice things about this reverse URL lookup, in that we can, there's some error checking that goes on, because if it could just blow up silently, and in many ways when code blows up silently, it's worse than, you know, blowing up in a spectacular fashion, because if it blows up in a spectacular fashion, you can fix it. So this is what it looks like. So this gviewcats URL and gviewcat42, this one that actually is the detail page that demands a parameter, it constructs that just fine. Okay? So that's going from the route application to the gview application. Now, you can also, this is kind of